after like basically fighting the system for 7 years, really not getting much recognition on any of my stuff. For a year and a half of my life solid, essentially doing nothing else, like working out and writing this stuff, 1000xing it, like the amount that you have to pass the existing by in order to get there is just completely unreasonable. And then, you can go to the same conferences and you can just walk by the row of papers and I can just like at a glance tell you, those results are not going to be better than random on like 9 out of 10 of the papers. It's a mess. Academia is a mess. But it's fine because, I can build tools that will help with research. It's just like, I'm no longer gated by having to publish stuff. So, that's fine by me. Raving JMLR reviews. Practical stuff. Yeah, I mean, that's pretty much the long and the short of it, right? Like, there were actually several pretty damn good projects on like infra side back in the day, and they just didn't get any recognition. So the authors left. I know one of them's at Minstrel now, having fun doing engineering on language models because, the RL community were a bunch of tools and didn't appreciate his like awesome eng work. That's how it is. Hey Lewis, we are working on the C vectorization backend with async CUDA buffering. We're trying to do async buffering host to device, device host. This will be a very, very big speed enhancement if I can get it to work. Okay, so yes, the thing that I was thinking about here before I went on that giant tirade, RL equal language. Yeah, exactly. It's dumb. It's fine. We'll have the field like well where it should be within a year or two. Ninsky is doing some cool stuff. I know. I collaborate with them. We ported their drive env to Puffer and made it 15 times faster. Work index end index. I'm trying to think what we do with this. It's very close. I need to do it's some check on the end index. FBR, academia will do the opposite. they will spend 1,000 times the wall clock time to solve it in like half the number of steps. Like, the wall clock time thing is an invention of pufferlib. Isn't that crazy? Like, basically nobody was even looking at wall clock. Welcome, everybody. Hang on. This is gonna get boring quick if I don't figure out this indexing, so let me figure this out real quick. I just have to check. All I have to do is come up with a way to figure out if the observations on CPU buffer is actually ready or not. Obs ready on CPU. Okay, so this is actually not... Yeah, so this is wrong. So this should be if atomic theoretical innovation over engineering. Yeah, but the thing is, they hard bottlenecked on engineering to the point that they couldn't make any progress anywhere else. Like, literally, the vast majority of RL published papers are just wrong. The results are invalid. Almost 5K on YouTube. That's cool. We're almost to 25K on X. So it's gonna be start index. Ugh, this is kind of gross, isn't it? I don't have any good way to get this index, actually, the way that I have it like this. Oh, no, I do. I do. Oh, yeah, I totally do. And, like, there's one of them I don't have to loop over. We do not make brain rot garbage. Chart index. I think it's something like this. Something like this. Just do... Okay, it's something like this. Let's now, I'm gonna go through this, and we're gonna figure out whether I think I've done this correctly, and then we're gonna see if I can get some of this debugged. Yeah. That'll be the goal. I'm gonna use the restroom real quick. I'm gonna see if I can get maybe another set of 3 in on the deadlifts, maybe. And we will continue. That work index run indefinitely. Yeah, I think the goal here, Daniel, is it should loop. It's a uint, and we're gonna have it so that it loops back around safely to 0. I think that's gonna be the goal. But it's kind of a tricky design. I'm gonna have to go through it a couple times. I'll be right back, folks. And then we'll see how far we get on this. I think if we can get something that is runnable today, I will be very happy. It'll be tricky, but we might be able to do it. And like as soon as I have this, it's gonna be. First of all, it's gonna be way faster, and second of all, it's gonna be really easy to test exactly how fast it is. We'll make like a little C test env that has 1-dimensional obs for like pure throughput, and then we'll make one that has really big obs for pure bandwidth. Right back. Specifically, I gotta figure out why the current version is deadlocking. I gotta add multifold buffering. Gotta do some profiling. And we do want to figure out how to buffer CUDA transfers as well. These are our goals. Also, this run is kind of funny. This is just like flatten coder. So this is the perf gap between flatten coder and the full architecture. But the funny thing is that this right here, this was the soda from Puffer 2, I believe. I believe this was like the soda from Puffer 3, somewhere around here. So, progress. Oh no, from Puffer... I forget. No, I think this was from Puffer 3, was around here, maybe 4. So, progress. Anyways. Where last we left our hero. Somewhere deep in the C threading dungeons. So this here was important, right? This is the pinned memory Alex. And then the question was why we were getting deadlocks. Let's actually run this. See if we can repro deadlocks. And lovely, let me reboot this container real quick. Probably have to do, yeah. We're gonna see how hard vectorization is to get right. Hopefully, it should not be too bad. Just me, or is this like super slow? Oh, it is totally slow. Why am I using this thing, man? I've been wondering for the last, like, week or two why my term has been slow. Let's go TTY. That thing is freaking slow somehow. There we are. Okay, so this thing runs. Let's rerun setup just in case. Yeah, that's super obnoxious. It actually does lag. That's way better. We're not seeing any deadlocks here. Okay. So, in that case, let me review the design of this thing. The way that this works, that's single threaded. You just Your comment on Elon's lol tweet. What did I write? Oh yeah, the long one. I don't know how it is that he doesn't have the context for that, given that he was involved, like, I forget when he stopped being involved with OpenAI, but, like, he had a lot of exposure to the Dota stuff or not. But, like, you are just gonna end up with a weird version of that. And it's not gonna work if you try to do it without, like, specific training. You're not gonna prompt the damn thing to, like, play League. Is it? This one? No, not this one. Where is it? Yeah. Like, honestly, if you read one paper in RL, you read the OpenAI 5 paper. Because, like, the OpenAI 5 paper just essentially, it's defense against the dark arts in some sense. Like, you see how simple this paper is, and then you see all the bullshit that academics come up with that, like, that doesn't even work on simple problems. And, like, this, honestly, was the most influential paper on all of my work. There's a lot of stuff I've had to figure out on top of it, but, like, this was the core. Frame by frame training. If you're going to train frame by frame on the actual game, yeah, you can do that. All you're going to do, though, is you're going to come up with well, like, you're going to have to do RL. You're not going to just generative model the damn game. No way. So, like, you're just going to come up with a vastly more expensive and stupider version of this. Actually, I think that there's even a Chinese MOBA where they did like a mini version of OpenAI 5 with even like less resources. They did it with like Han or something. So you're literally just gonna have gotten crushed by OpenAI and then like some random couple like Chinese groups as well that still work on games. Like, cool, I guess. Honestly, that's not the new frontier though. The next frontier for RL, in my mind, it's always been like get it to play an MMO. Then we'll talk. But the thing is, like, even if you get the thing to work with a big pre-trained model and like plus some fine-tuning, the conclusion is completely different from if you get it to train from scratch. Large model plus R. You can do it, but like it's woefully inefficient. Actually, if you want to see somebody who actually has a chance of doing this, Pim replied to that general intuition guy. They actually have enough data that they can train across a ton of games and get like a pretty good baseline model. But it tells you different things, right? Okay, so there are a couple of problems here I'm seeing with this. Is there? Yeah. Hey, FBR. Yeah, it's the intermediate must-do steps. It's like external knowledge is what it is. But I intentionally don't really work on that area, Ice, because like the stuff I work on is it's stuff you can actually do on a reasonable compute budget. Like these graphs here, each of these graphs, this is 650 billion observations. This is over a petabyte of data. So I have like way more data here than is used in all of training of any of the language models. And I can do this on one server. Like you can kind of get the sense I can get completely different insights out of the style of work that I'm doing without even being compute constrained versus what you're going to be able to do with large models where you kind of fundamentally need the compute. Okay. I think we need to figure out. I don't think how I want to even formulate this. Because there's a thing that I need to know. You're going to have to write papers that suck. Typically, getting papers accepted requires writing papers that suck. Kind of an awkward. So what I'm trying to figure out how to do for reference right now, folks, we have this basic vectorization, and I want to add like multi-stage buffering to it, so it'll go through the first chunk of M's and the second chunk of M's and the third chunk of M's. That's pretty easy, but I want to do it async. And there's like the CUDA device. Hang on, let me think how. I have to think about what I want to even do clearly, and then I can figure out. Because it's basically just a couple sync mechanisms I have to look up. The idea. Okay, I think I know. Is there a way? I see. Okay, this is not bad. Kind of tough. Sub-millisecond songs. You can run with 104. Is it a tiny? Oh yeah, 200 params. $200 params, you can almost run that. Like you can almost run it like that fast on CPU. Probably can, right? Honestly, at that scale, I'm probably better off doing evolution. Models can get IMO gold. They can solve any games. That is not true. That's not remotely true. Ask an IMO gold medalist to come up with like strategies for like Dota if they've never played it or something. They're screwed. If I get this done in time, yes, Roger. And provided I think I'm allowed to do that, right? You're allowed to do I think you are allowed to watch content like that on stream. Right, so what I want to do, yeah, okay, I think I formalized how I want to go about this. Said about the intuitive side. The external knowledge is less so strategies and stuff like that, Ice. The external knowledge is more so... It's like when we were trying to solve Pokemon, right? And, like, they give you text instructions of what to do next. Like, you can't just train on the game being unable to read and know what to do next from there, right? It's stuff like that. I mean, like, technically, even stuff like the graphics of the game informing you on what to do, right? Like, or the text on what items actually do is another good one. The thing is, like, for a lot of these, you can kind of just brute force it with samples by trial and error, and that's actually totally fine, and oftentimes more efficient. But for stuff that's, like, really spread out, where you can't brute force it, then you need some external knowledge, which is why I specifically say it should be 99.9+%, probably more than that, RL, and a very small amount of high-level guidance. That gets 10x your LLM results with LLMs. Wait, 10x your LLM results with LLMs. What? What does that mean? Yeah, because I don't want to invest time in getting good at using LLMs, because I think it's a shit way to go about programming. You're basically managing out, and in a year or two, when like the little bit of control scaffolding you're doing is automated because it's really fucking easy, you simply have no idea what you're doing, no idea about what's going on at a lower level, and no value whatsoever. Passing unit test does not mean your code is an ass. Some of the people I know who write the worst fucking code I've ever seen have tons and tons and tons of tests. It's still a buggy mess. There is no substitute for simplicity, and there's no objective way to test simplicity. Ultimately, I'm simply choosing to bet on myself. And, like, it seems basically impossible that's a bad bet. Like, I'm not going to ask it to write me a piece of code here, right? Like, I'm going to use this as fuzzy docs. Welcome, convert, yeah. I asked the other day about multi-objective. You can already do it. That's very different. I want to rank preferences in action spaces. GP. Rank preferences in action. GPI. Rank preferences. Do you have an example of, like, the problems you're interested in? Because currently the best way to do multi-objective is goal conditioned. I'd have to see your problem formulation to see if it makes sense. You can absolutely use Puffer for research. It's just like, it's more complicated than CleanRL, but way simpler than SB3, and 1,000 times faster than either of them. And there's convert on all three platforms. Welcome, Rat Swag. We're gonna do vectorization stuff today. Honestly, Roger, that would just be called a parenting failure more than anything. Like, LLMs are not inherently bad. Actually, they're quite good. It's just people doing stupid shit with them. Welcome, off market. Hang on, let me at least, like, let me finish this thought and finish this query first, because this is actually kind of a complicated thing. Sorry, I'm fraud. I meant I want to rank objectives and construct a Pareto front of good policies. Oh, okay. I want to rank objectives and correct a Pareto front of good policies based on that ranking. Currently, that is done by weighting / scalarization. I don't know what you mean by weighting or / scalarization. You can very easily do that now. So, Hyper, one very simple way of doing that right at the moment without changing anything about the algorithm. So you could imagine that you have a bunch of objectives defined in your environment, and the policy might learn to complete one or the other. And then you have a reward function that has a few different components related to different things in the environment. You can run a hyperparameter sweep that includes the reward coefficients, right? And then you can track in the logs, you could track the completion rates of different objectives. And then you could map essentially all the different runs that you've done with all these different weightings of rewards into the ordering or the total score, however you want to do it, across all these different tasks. This is actually something that we do quite often for our own work. Like, this is pretty much one-to-one with how we tune complex environments. Yep. So the problem with doing everything in CUDA like that, FBR, is you're not going to have a fun time with complex ends. I'm pretty sure, at least. To be fair, I have not gone through the effort of like port neural MMO to CUDA to see what happens, but I'm pretty sure that if you have a full game with a whole bunch of branching logic in it, it just will not be fast in CUDA. It calls like a ton of syncs, different type of sync, but a ton of syncs. Yeah. Parse this in the video. Yeah, you can ask me more stuff about this if you want as well. Like, this is why I stream. But if you go just take a look at neural MMO, for instance, like that's an end where we have a few different reward coefficients, and we sweep the coefficients themselves. We only have one like overall objective that we monitor in that because we made a joint objective out of multiple distinct objectives to give us a single real number metric of performance. But you could equally as well use this for multi-objective. Like in neural MMO, there's a profession level and a combat level, and we just define performance to be the minimum of your profession and combat levels. But you could very easily come up with something, right, where like you tune one way or the other, and you see, how good you get in one objective versus another as a function of reward coefficients, stuff like that. Hi, Jess. Okay. So excited to do everything real world to get the drone demo working. Oh, I'm new to RL, but I want to contribute to Pufferlib. Docs on puffer.ai. Did I add the guide there? There's ice. Yeah, so there's the guide here. There's this like getting started thing. And then there's also for educational resources. These two guides are a good place to start. My ex. Okay, so this wrote me way more shit than I wanted. Let me see though. Okay, so you allocate. This is going to be allocated on CPU. This is a CUDA malloc to GPU. We're not going to worry about the CPU fallback yet. If ever, honestly. We might just do it so that the C++ backend is GPU only, because, like, why the fuck not? You can use PyTorch CPU fallback otherwise. Pre-existing stuff to more realistic environments. You definitely look into how we do our environments then, because the way we do everything makes it super, super fast. Like, 2 to 5 million step per second training in Puffer 3, and ideally up to 10 million in Puffer 4. Whose is this? Okay, De Silva. The hell? How are these multi-objective? These are just like standard M's. Aren't they? Oh. Oof. Oof. This axis, when I see an axis like this, I immediately consider all results invalid. This is not a reasonable number of steps to be doing research with. I don't know, I would just go, like, if they have some grid type M's that you can actually scale up to be appreciable tasks, like, these things are a few hundred lines to implement, and you can train, like, this axis can be billions very easily. You can really test whether something works or not. So how do we actually use multi-objective environments is the point. Yeah, you basically figure out an environment that you'd like to use, right? Look at the way that we build our M's, port something over, and then you can very, very easily have the largest scale training results on any multi-objective environment out there if this is how slow everything is. Hyper, let me show you something. This is neural MMO 3, right? These are 650 billion step runs. This is our hardest environment. So we do, I mean, this is same order of magnitude-ish as, like, all of Dota. We just do, like, massive, massive amounts of samples, and this is on one server. You don't have to do something this crazy, but, like, I mean, as a standard, we're typically running M's for like few hundred million at least. Doesn't even take long, and a few hundred million will be a couple of minutes very often. The harder environments are billions. If they're doing 0.2 mil steps, then what's going on is like you're just working on very easy problems, basically. Which is, it makes sense if you look at the M's. You're just like, you're working on very easy problems, and if your stuff is that slow, like, you're probably not even running hyperparam sweeps. Very few papers actually do. You're working in very, very low batch regime as well, which is crazy unstable and inconsistent. It's just not a good way to do research. Yeah. I mean, it's kind of crazy just the gap in how we do our research in Puffer versus everything else. Like, I don't know, like 0.2 million. That is, and is that like 5 or 6 orders of magnitude gap? Yeah, like that's crazy. Would you attempt to go over the math equations on page 7? Multi-objective toolkit RL. What, this? Yeah, I don't exactly understand this either, man. I get roughly what they're trying to do, right? They're trying to mostly define, like, this is diversity given a set of different weights. I could go over this. This would take me a while, though, dude. It would take me quite a while to go through their, like, what they mean by this. This does look like some... What's this V? F equals V. I don't know what V is here. Yeah, I'd have to go over this in quite a bit of detail, man. This wouldn't be quick. Congrats on Soda. Would you ever tackle NetHack? Javier, if somebody makes it fast, I have a few colleagues that like want to do stuff on it. They're like, there's just some engineering that has to go into it to make it fast. Because like the base env is decently fast, but then all of the wrappers in Python are just god awful slow. You really need your environments to be at least a few 100K steps per second per GPU in order to make appreciable progress. RL gods? Oh, Roger, but that's not my forte. Like, my playbook is probably, it's 80% engineering, 15% basic science, 5% stumbling through math. Like, it's like the weakest thing in my toolkit. I do stuff occasionally. It just takes me way longer to stumble through things. Multi-objective value function? What the heck? They have a multi-objective value function? That's kind of wonky. You have to define explicit objectives. If you're going to define a value function that has like different values for different objectives explicitly, it's way cleaner to just do goal condition, in my opinion. Like, goal condition is actually pretty easy. You can get like one policy, right? Doing tons of tasks in the same env. Oh, right, I was looking at this, right? Okay, so pin memory, this is what I have. This is just allocating to GPU. You create a stream. This is not bad. Oh, and you can just do this. That's actually easy as hell. That's so easy. Okay. So now I suppose the only question is, do I want to keep it one big block of obs on CPU? Actually, yeah, this is a question. Ooh. This is so funny that they say this is actually the preferred way in all production RL systems when like literally none of these things have anything this sophisticated. Never write to the same memory. Okay. This looks good to me, guys. I think we can make this work. And this is actually nice because I can test this. I can probably test this before it gets too hairy. Made promotion cleaner and chess is learning better. It took one build steps for it to figure out some bug, caused perf spike after hovering around 0.5, like should. Bug hunting night. Very fun. I actually really like this. This is like this is actually really chill. So, because all we're gonna have to do here, right, is why do I have void star star? Oh yeah, because that's just how it works, right? Check observations. So I need vec to be is there anything else? Yeah, this everything needs to be yeah, everything needs to be transferred. So I think this is fine. No, Grok didn't cook, Jess. Grok was fuzzy docs. CUDA. Right? Yeah, this is fine. So now we have allocated on GPU. And then this is going to become CUDA mem copy. CUDA mem copy. And we can actually do host to device, right? And we can do the same exact thing here. We can do CUDA mem copy. This has to be dest is vec actions device to host. I think this is right, no? And now the difference with this from before, this is actually going to be a very nice piece of infra. Because, look at this. We get to take, we just get to do actions, hang on. Pufferl env obs. There's obs. I think we can just do create environments, right? Create. This can be GPU everything. Torch from I love when it says, and the way every high-performance RL codebase does it, when there are literally 0 codebases that do this. I do not love GPT. Alright, there we go. This is solid. Yeah, this is gonna be solid. And that's almost it, actually, right? I think that's actually it. So now, was your best one? They all suck, man. Just don't overuse them. If you're basically using it as docs rather than trying to get it to write code for you, like, look, am I trying to get it to write logic here for me? No, I'm trying to figure out what the signatures are for, like, CUDA device transfers and stuff, because I haven't used the, like, low-level CUDA API like this before. I'm not even, like, not even looking at this crap. Pretty much all I care about here is the fact that I can do this. Hang on, does this run? Okay, I need the CUDA trace or the CPP trace. Oh, I forgot to turn the lights on the flag today. Thank you for reminding me, Roger. I should get my deadlifts in a second anyways. We'll fix this bug and then I'll go do that. We'll turn my lights on. We're gonna see how the deadlifts go though. I went running this morning today. It was just absolutely awful. It did not feel good at all. I'm using Grok at the moment because it got faster. When Grok was slow, I was using Cerebrus because it's fast. Okay, that's weird. Oh, you know what? I think I know what this is. There we go. I just forgot to rebuild. Dude, just ignore the fuckers. It's really that easy. Cool. This runs. So now we have our nice new vectorization. And all I have to do is I have to buffer this, and then we will have the fastest vectorization out there by a mile. That sounds pretty cool to me. And I think this is totally the right way of doing it as well. Like, the sample factory design is quite bad for lots of ends. This is going to be a way better design. Way, way better design. Actually, you know, I really don't think deadlifts are going to be a good idea today. Huh? The GPU and not data processing. Go to publicly, yeah. In a world where intelligence isn't a bottleneck, like, problems are all solved. And there is, and scarcity is solved, and disease is solved, and aging is solved. Everything is just solved. So until then, planning on the LLMs doing everything for you is just fucking stupid. If you're like, oh, intelligence isn't valuable, let me find something else that is. No, there's nothing else. Because the thing is, most of the soft skills are around, like, trying to manage intelligence, which goes away if you think the LLMs are going to be smart. So yeah, it's just like, most of, like, let me, like, assume the LLMs are going to do the deep technical thing is just like saying, I'm going to be lazy and be completely worthless and not actually bother try to understand anything ever. That's why the discussion is just, it's stupid. All right, let me go use the restroom, turn the lights on, get more coffee. But apparently, my muscles did not get that message. That's 375 for 5, just fine. It was hard, but no harder than it was last week. Weird. All right. We do buffered vectorization now. Laws against patenting things in the UK classified as a world-changing discovery. You can You can join us in the US, the real country, as the stupidest law ever. Like, way to go, completely disincentivizing any sort of actually important invention. Real country for now, agree. We are completely taken over by Canadian geese here. I've got tens of thousands of them. I'd like to send them back to Canada, thank you very much, and exchange them for some harp seals. Are they tasty? They don't seem like they'd be tasty. They're okay. You eat the Canadian geese. Huh. We'll keep that in mind. Had a few. I don't even think you would have to shoot them. I think I could literally just run and grab 2 of them. They just sit there. They're eating all, like, the leftover corn kernels from the harvest. Could bring back a goose for Thanksgiving. Just say, I brought it, you cook it. Hide. X Premium, some anniversary thing. Yeah, it's definitely a hell of a lot more than $1 on this. Oh yeah, I did launch, the cool thing from X lately was that I got, well, it doesn't actually show me my own subscription for some reason. But, where is it? We launched this thing for companies. So companies can just sub for $200 a month to get, like, entry-level support if they don't want a minimum $10,000 a month contract with us. So I figured it would be a nice way to get, like, people doing some amount of professional RL and wanting to have a little bit of guidance, get something out of it for way cheaper. We'll see how that goes. Mini product launch. It's the funniest thing, Convert. Basically, everybody's like, well, you wouldn't go kill a goose, would you? It's like, I am absolutely fine doing that. I just don't want to have to clean the damn thing. Man, get it. Alright, this is not caveman chat, though. This is... tasty goose good. No, we do RL. RL hunting bot? Yeah, we can train the bot to go catch chins on RuneScape. Alright, let me think how we're gonna do this buffered transfer thing. A local rabbit from the park grew up. Alright, that's kind of messed up. Like... There's a total difference between having, like, you know, this is the pet rabbit and this is the game for dinner. Friction in Isaac seems wonky. Oh. Yeah, I do not believe them when they say that about domain randomization. They're doing it wrong. I've seen the robotics code. They're obviously just doing it wrong. They use RL games and shit for training. They use really shitty libraries. I think how we want to do this. So we don't want to pass indices, right? Because indices are slow anyways. We can probably do it based on buffer index. We can do like int buffers. Let's do int buffers. Int buffers. Like this. And that means we need ordering structs to reduce memory padding. Dude, there's one of these. How is that relevant here? There's literally one vecm struct. Oh. Not really. We're never memory bound anyways. I guess it can help with caching, but that's like pretty minor compared to everything else that we do. Can I do this? I think I can. Do we include the CUDA runtime? We do this? Okay, this is fine. So we allocate streams. We create like this, and then this is gonna be and back streams I, right? Like this. Now we have our streams. Now we do int buffer, right? So we just do int start equals this. Size. I'm gonna probably watch the podcast on stream later if I have time, Roger. My current impression before watching it, though, is like, from what I knew about Ilya and Sam, I would have stuck with Ilya in a heartbeat. Like, no brainer. But it's kind of good that he has his own thing now that he can just do whatever the fuck he wants. It's honestly way better than him even having like just staying at OpenAI or whatever. Yeah, Sam is like the YC and Quora guy, and Ilya is like AlexNet second author and Seek to Seek first author, and like probably like one of the most brilliant, best spoken people I've ever met. Not even close. Oh, okay, shit. This is gonna be. This is kind of awkward, right? Yeah, we can still do this for now. Yeah, we can still do this and test it, and then we're gonna have to go to the send receive API. No, convert nerps nearly killed me last year, so I think I'm taking a pass on that. Literally took me an entire year to get back in, like, about the same overall physical shape. I think I'm slightly weaker than I was back then, but also a bit lighter and leaner, and also a bit faster in running. So overall, about what I was before that. Ugh. Ate too much there? Yeah, bro, that was totally what it was. Was in the hospital with pneumonia for 5 days, dude. 105 fever when I got there, and like less than one full lung to breathe with. If I hadn't been in such good cardio shape at the time, I would have been dead. Exactly. So why do we have this actions thing? I need this. Alright, so this is what we have. Included. I'm not hinting at some sort of AI winter, dude. AI is legit. Like, AI can simultaneously be legit, and there can also be like a lot of dumb bullshit around AI from grifters trying to make a quick buck. Yo, what's up, Zoomer? Hey, Syntax. What's this in the CUDA API? This for now. Too many arguments. Yeah, there it is. Okay. Start. Joseph Nut paper. I'd have to come up with something. Okay, we are hanging somehow. Well, because I didn't. That's not even correct. And yeah, there we go. This dude. Performance engineer. Who's the most cracked puffer lip guy in X who started some time ago? Depends how long ago. Spencer's kicking ass right now. Jess started way more recently and is getting some pretty good stuff done with chess. Bet didn't get, like, has not done stuff at the same level as that, but he also started with, like, literally no programming experience. So from where he started, he's done some pretty damn cool stuff. That's funny. Yeah. Yay, it works. Look at that. We can write some CUDA calls without breaking things. Bet. So Bet did, what did Bet do? I mean, in addition to all the advertising he does, Bet did, the best env is Enduro here. Oh. This is a pretty cool env, right? This was like a way harder project than I expected. I should not have given this to a total beginner. And this is a pretty cool env to watch. Like, it's just like one of these, like, really clear-cut superhuman. We should ship a better model for 4.0 for this. I think if we, like, reduce the entropy, it'll stop jittering so much. You literally reward it for jittering with entropy. So it is possible. Look, I make it way easier than it was when I had to learn this shit, okay? It's still gonna take some work. I've made it as easy as I possibly can. It's still gonna take some work, I'm not gonna lie. But I've put together a pretty damn good set of resources for anybody who actually wants to learn. And they're, like, focused on teaching you shit, not just, like, fucking with you and wasting your time. Alright, so we got basic vec. So the next thing we have to do with this is the send receive API. Let me explain this real quick before we do this, also so I can get my own thoughts right. Actually, I have this in the Python. All right, so in the current Python Puffer 3 version, we don't actually use vecenv.step, okay? We have a two-part API. There's this vecenv receive, which gets observations, and then there is a vecenv.send that sends actions back. And the idea between this is you can send actions back, and this can be done async, right? And then this receive is not going to be getting data from the same envs as you just send actions back to. $25.40 ELO online. Yeah, I can't even beat, like, the 1500 ELO bots, dude. I'm bad at, like, virtually all games and all puzzles. We have multiple chess people in here, it seems. Perfect. We have 2 people who can go look at Jess's chess thing and tell tell us if it is any good. Because honestly, chess is going to be probably like the best self-play end, right? Because like keep in mind, we're going to do it without search. So like self-play chess without search is probably pretty hard. That's one of the bigger projects going on right now. If Jess is still here, go ahead and ask like what you need done. What he needs done. Oh yeah, it's Discord GG/puffer for all the dev. Also, since we have a bunch of new people, good time to mention feed the puffer a star. He's hungry. Click star. Feed star helps. Welcome, high potential. Well, everybody is better at chess than I am. Domain translation model. Cool. Welcome to stream. We're currently building a C backend for vectorization. And the big thing we're trying to do right now is buffered GPU transfers. Hey Jess, there you go. You just got yourself some high elo feedback for your agents. You're in the right place to play around with RL. This is pretty much the only spot you can run RL at home and actually just have it work on very limited hardware. Puffer is fast. Puffer is very, very fast. And so we need to add vex step, I believe. I think the easiest way to do this is just like type def like this, yeah? And then we can do vec. So this is a really, really far cry from chess, Ice. But like, I think I kind of get the type of insight that you develop when you get better at chess. I have like a stupid number of hours growing up on this MMO called Dofus that's like tactical fantasy chess on steroids. And I remember that like over time you kind of just develop this vision for like you see what's just going to happen in the future and your mind just automatically discards all the stuff you don't need to think about. I'd imagine it's probably a pretty similar feeling to that. Kind of like that. I figured. I know, it's kind of a weird feeling. I never got into chess. I tried a couple times. TPU support in libs like this. So the problem is TPU support at this point basically means Jax. And Jax can go fuck itself. So yeah. I am actually, if you're interested in that though, I am going to be doing a Thanksgiving Day stream tomorrow, in which I'm going to be trying out TinyGrad. And Tots, or at least whoever runs the Twitter account, who I'm pretty sure is Tots, that'll look at, he'll actually like look at whatever benchmarks I produce out of it. So yeah, so that would be you can probably get that out of a lot of games, but they'd have to be like PvP games. You're totally right that you get like limited to one path though, and anything that's first is a predictable AI. Shut it up for Twitch integration. Neural MMO, we just got Soda here, pretty recently, and you can look at it in your browser. It doesn't have all the same number of agents or anything, but there is a playable version in your browser that has the AI. Like, this is hands off, right? The AI is playing it at the moment. This is actually the hardest benchmark we have by like at least 2 orders of magnitude. Like, Neural MMO is by far the env that we use to test like whether something is actually better or not. Any idea why? Why it's so hard? I mean, play it and then play any of the other M's. Like, it actually has some pretty like long-term reasoning and stuff associated with it. And there aren't other environments where you can just drop 1,000 agents in and have them do anything that's that sophisticated. Like, there's leveling, there's armor, weapons, equipment, tools, gathering stuff. There's market, agents can trade with each other. There's a lot of stuff going on. Just a complex env. Yeah, we'll see. So I believe him if he's going to tell me that TinyGrad is like a better Jax. I don't know if it's going to be. It depends how much low-level control it gives me, right? I mean, he says it outputs CUDA, it outputs kernels. So like, if it will output actually like usable kernels that I can paste in and then just compile and run with those kernels bound to anything, then that is awesome. So we shall see. What's a complicated RL that would have a super fast per step computation? I mean, Neural MMO is pretty fast, Kinbert. Like, the only thing right now limiting Neural MMO is it has 1.7 kilobyte OBS, and the host device transfer kind of gets you a little bit on that. But like what I'm doing here is literally gonna fix that. Like, I'm pretty sure we're just gonna eliminate that completely. Because I think technically you should be able to get 32 gigs of transfer, right? Like 32 gigs a second. So if I get anywhere near that, this just doesn't become a bottleneck. Hey, Son of Liberty, we are doing async async buffered CUDA transfers in our vectorization backend. So we're going to eliminate the overhead from going back and forth from GPU to CPU. That's the goal. Pretty much it, isn't it? Vec send, vec receive. Try this. What is the secret sauce for reaching soda? Mingru. We got a new Mingru based architecture in Puffer 4. You only get that info on the stream though. And it's still gonna be a while because Mingru is we still have to make the architecture fast. It's going to be faster, but it's just harder to optimize. Since you're writing kernels, have you checked out XLSTM? Javier, we just got soda with Mingru. So I think XLSTM is too heavy. But yeah, we got it with Mingru. The problem with all of these though is they're really obnoxious to implement fast. So I'm working on it and it will be faster, but it's really obnoxious. Mountain car is not hard, FBR. Yeah, sorry, that does not count as hard. I have this idea, because, since I've been writing kernels, the insight that this has given me is, like, the way that research works right now is you have a whole bunch of scientists who have no idea how to program anything or how a computer works, just, like, trying different architectures. And then you have a bunch of overworked engineers being like, how the fuck do I possibly implement this thing fast? You could probably come up with some good architectures that are just really easy to get max flops, like max throughput out of. I think that's probably a pretty promising way to go, especially with smaller models where like overhead is really hard to optimize. You could imagine that we come up with a model that has 100K params that also runs at the exact same speed as models run now, but is using 100% GPU, right? Okay, this still works. Lovely. So, now we need to async this. I think we can just async this, can't we? What happens if I just do this? It's so funny to me how this is like way easier than the Python vectorization work I had to do. I have to read that thing. That looks really cool. It's completely insane. I don't know whether it'll be useful to what I'm working on. I'm very suspicious of like Evo low rank updates in general. I would suspect that that's useful in LLMs because LLMs have like really shitty RL. So like the fact that Evo is better actually just is funny because it just means the LLM people are trolling. Um, I'd be surprised if you beat like actually good RL on models where you can do it, but I have to read it. 17 param. That doesn't do much for us, man. We're not trying to get like. First of all, you can't get 300 mil. Getting 300 mil SPS on that when you're not just doing like the whole thing in a kernel is very hard. Like if you look at some of the kernels I've had to write lately. I mean, heck, you're not even using really your GPU properly, I'd assume, right? Like you're probably just doing your matmols manually or whatever. Like it's not using the tensor cores. If you're just writing a custom kernel and like doing a matmul manually, you're not even using like the dedicated matmul um cores on your chip. I mean, it's cool. And actually, if you wanted to look at like Evo based stuff, that is kind of the way that you would do it. Um like for Evo based stuff, I think that some of that could even work now if you made stuff just stupid fast. And honestly, the egg roll thing that they made, like the doing low rank updates, is a really good idea. I don't know why that never occurred to me. But like the thing is, if you want Evo to work, this is where like you go get 100 mil step per second training. Like you just accept stuff is going to be more general but less sample efficient in general. All right, how did I break stuff by doing this? Let me think. How do you debug this shit? It's not that complicated at the moment. Oh, believe me, I love my breakpoints, dude. And if I need them, I will absolutely like I can get breakpoints into this stuff as well. But at the moment, I'm making very small changes, and like this is just for some reason this thing is. Like, I don't know why this thing is above 0. That doesn't make sense to me. Oh. Oh, I see. Didn't realize you had your thesis video on YouTube. Just watched it. Yeah, I uploaded it and it did pretty well. There's also the iceberg video on there. Is a pretty decent piece of content. Looked very different compared to back then. I mean, I was all dressed up in a tux. And I had not fought, I had not spent 2 years fighting, like, you know, a low-level RL demons from hell. Takes a toll. Building is a tough one, Ratswag, because you have to make sure that the agents can't grief the environment into an irreversible state. Building with a decay system works. Like, if you think of like Rust or V Rising, like those style of games have a building system that absolutely would work. Look better now. Heh. I mean, I am pretty lean now. I'm leaner now than I was then, for sure. I would like to get a bit of the muscle mass back on. I think that's going to be the plan for the next training block. I usually go to Florida for a couple months in the coldest part of the winter. I got to get some PT for my shoulder because it just never healed right. So I don't know if I'm going to get like shock on it or something, but I got to get my pressing strength back so I can train overhead press. And then I also have to start squatting again. And then I'm probably going to do like a pretty heavily hypertrophy focused block while I'm doing that and see if I can get some weight back on, but get it back on lean. And then I have to figure out how to maintain my cardio well enough because, like, it just sucks running in Florida. There's not, like, really a point in me trying to get, like, to really improve my cardio there because the training just sucks there. Yeah, Rat Swag, you basically get, like, 2B2T type stuff. Except, like, worse. Think, like, completely unregulated Minecraft server. I'm in Maryland right now. Honestly, not even cold yet. Today I ran in a t-shirt and sweatpants, and I was hot. It's also called. Is also. There is a cool gym that I go to in Florida. They have lots of good. It's like there's a local powerlifting gym that's just. It's just absurd. Um, I've seen guys pull like 650 in there, and I think 3 different women pull above 3 plates, and 1 woman pull like 400 in there. Crazy gym. Oh yeah, Jess, where do you think like I know about all the gaming, man. Like where do you think I get all the inspiration for all these M's and like, all this game RL comes from? To be fair, the vast majority of my hours are in a couple different MMOs, but played other stuff too. Way less now cuz work constantly, but I don't know, I've been playing Evan Shore lately. It's been fun. Giving me ideas for Neural MMO 4. Thinking off tomorrow? No. Tomorrow we have a special stream. I'm going to be trying TinyGrad. We're going to see how that goes. I'm trying to figure out how I want to do this. Because comic load explicit. Wait for all threads to initial. Ah. You know what? What happens if I do this? Yep. That's it. What I thought. Do we learn? Yes, we do. Boom. Okay. We're gonna commit this so I don't lose it, because the next thing we're gonna do is a little sketchy. Cool. I do need to take some time off though. I don't know. I can kind of tell that like my mental is just stuff's getting hazier. It's like I can kind of tell it's time for me to take more than an hour, like a few hours here, a few hours there off. Uh, but they're like just there are a few more things that need to be done, man. Like it always is. So for now, I'm kind of just being satisfied with taking a few nights off here and there. Hmm. So unfortunately, the design has to change a little bit to support this. So what we have right now is we have the API the same, but under the hood, this has to support like multiple different buffers worth of ends. And I gotta think about the way that I want this threaded. I know. So Ratswag, usually the way I see it is like when I don't want to be working, it's usually time for me to not work. Because I kind of just like with all the exercise I do and the amount of like stuff I crank out, I kind of just trust that I have a ton of discipline in my work. Not trust, like I've kind of like just I show it to myself for constantly. So whenever I'm like I don't feel like working, man, I just go, okay, I need a break. Because normally I want to work. So if I don't want to work, I must just be tired. Oh, Sanjam. Oh, and before I forget, I do have to check. I was expecting one client inquiry. Nobody. No, I don't have any reply. Fine by me. Okay, so the ways that we could do this, right? Do we want to have... I mean, the simplest way... We don't really need to have multiple blocks of threads, do we? Like, we can reuse the same set of threads. Ooh, wait, can we? No, kinda can't. I mean, I can initially, but it's gonna get more complicated anyways. Okay, so there are a couple things going on here, right? We'll draw this so everybody can understand what's going on. This is actually kind of complicated, just a little bit. So we have a bunch of ends. Okay, and then we want to go over these in blocks. So, and then here we have 3 buffers, which are just partitions. And then what we want is this gets like obs action. And obs okay, and then you have like your model, Your model actually is going to just be like taking in obs and actions from different m's at different points in time here. But the problem is, how do we synchronize this? Because like on reset, let's say on reset, right? You already have available your obs, but then none of these are synced. So what happens is when you get actions here, what really needs to happen is there needs to be something needs to say, something needs to wait for sync. This can just be a thread. So you need an extra thread, I guess. Don't you? Yeah, you're gonna have to have an extra thread. I think you do, at least. Let me see. When you send actions to the end, right? Oh, yes. Yeah, you do. Damn, that's annoying. Hey, Tim. Well, I have some idea of what I need to do with this. So we need to have an extra manager thread here. And that manager thread is going to be responsible for basically checking when CUDA device transfers are done and actually like starting up the env computations. Here's the diagram. I'm gonna use the restroom real quick. I'm gonna get more coffee, and I'm gonna see if I can get a second deadlift set in, and then we're gonna work on this. Casually taking a break. Pull 360 to 375. Thank you very much. I am not autistic. I understand the mistake there. But I am not, in fact, autistic. You could be excused, though, based on how I do things. Does Python handle all this fast? No, Python actually makes it way harder, Tim. And basically impossible to optimize. 350? No. Because I got 5s on there, right? Let me see. Yeah, I got a pair of 5s on the end. A 375. Yeah, you can't see them from here. My best ever was 410 for 2, but that was when I was over 15 pounds heavier, and with straps and with a belt. So the first set today was 375 for 5. No straps, no belt. Down 15 pounds. I only weigh like 170 right now. I'm pretty light. I managed like I think like a 630 mile a couple weeks back. And, some decent 5 and 10K times. Good PRs at least. We don't need that. Tell and convert something. That is why I'm not going back to NeurIPS. How much do I sleep? Not enough, man. I'll sleep 8 or 9 hours and I'll want like 11 or 12. Clicky keyboard. Widow Tournament Edition V4, 75% with orange switches. Not super clicky. No numpad. You don't need the numpad. It gets in the way of your mouse with games. Not that I'm playing anything competitive these days. This has been my favorite keyboard so far. I really like how every time I buy a new Razer thing, it's actually like tangibly better than the previous thing. Like they actually keep improving their products. Alright, so this has to go to Async. Naga. I've got a Death Adder V3. I've used Nagas of the MMO mice, right? Yeah, I've used those a bunch. Actually the Hex is a pretty decent one. If you want some buttons but not a ton of buttons, the Hex is pretty decent. Yeah. Shitload of buttons. Yeah, I don't know. It's like, it depends on what you're doing. You don't always want the buttons on your mouse hand. I think at like the sweatiest, I had some stuff on the mouse, and then I had like 1 through 7, Q through Y maybe. Oh, and then you can also do shift modifier. All right, enough of that. Let's get this done. So the thing that we have to do here for the threads. All right, so we have to do vecthreading. Threads. +1. Last thread is sync. Work stuff? Are you kidding me? You use a Naga for work? Dude. That is insane. You literally use, like, the MMO mouse for work. Just so everybody can realize how ridiculous that is. I gotta show this real quick, guys. Like, where is it? Alright, that's what this mouse is. Okay. This is gonna be our last thread. We extend. Oh, yeah, and then this thread just has to get its task, right? So this just has to be... Need to be one function or two? Thread. Well, I mean, we can start by just making vexend. Thread step. Oh no, we want to make this a little different, right? So this is C thread step. So we can just make this void C thread manager. Like this. Yeah? This thing. Don't need this. And we can do we kind of need to think about the design of this thing. Because, okay, so these guys are no longer going to wait on num running threads, right? Happy Thanksgiving. That will be tomorrow, good sir. Do I want circular buffer? I think I just want to do I think I just want to do a circular buffer, right? So instead of adding num threads or anything like that, it's just we're gonna add like tasks. So all then we need is we need an index and we need a tasks remaining. And then C thread manager. C thread manager also needs some stuff to sync. Yeah, so C thread manager is also going to need a couple things to sync. C thread manager is going to want to have C thread manager one's kind of awkward, isn't it? How do we do this without busy waiting? I guess I could do this busy waiting to start. It's really easy with busy waiting one thread, isn't it? Pretty sure it is. Now the only thing that's a little tricky I think we need send streams and we need no, we don't need multiple streams. Actually, let me ask something. Okay, so we're gonna get single stream. And then we can just do ready, right? Yeah, we just need to have a ready thing. But I think this is easier. Okay, yeah, I have an idea on the design now. Yo, Peru. We are doing some major stuff with your code right now. I am making it double or n-fold buffered, and we are doing async CUDA as well. Which, if I do this correctly, we are going to completely eliminate the biggest source of overhead in like HyperFRL. When did you learn CUDA? I didn't, dude. I just kind of started doing it. Like, I don't know, it's C that runs on your GPU. How hard can it be? I've done multiprocessing. I've done C. Just start writing it. Okay, so we're going to get rid of this num running threads. Trying something a bit different. Hang on, let me see if you're doing the exact same thing I am. So Peru gave me the initial C thread implementation that I've been working off of. Where Peru? When eval, mainly to get each eval per env horizon per tight loop of get action. Batch to batch independently in different threads. Not quite. Okay, so let me explain what I'm doing to you, Peru, since you did this. So what I am trying to do is, let's say you have 8K envs, and you want to split this into 4 buffers of 2048. Then you reset all the ems. You have all of the obs available. You consume the first 2048 obs by passing through the model, and then you asynchronously pass the actions back to those first 2048 ems. And in the background, that's going to do it's going to wait until CUDA syncs. It's not going to force it to sync. And when CUDA finishes syncing, then it is going to step the ems. And similarly, you get the second batch of obs from the 2048 to 4096 ems. You compute actions, and by the time that you get back to the first set of environments, you're going to have obs already ready for you and already loaded into CUDA. So the idea is that if you do this correctly, you will never bottleneck on transferring actions to CPU or on transferring obs to GPU. And then it's going to be very easy for me to write a test, right, where I test max steps per second throughput of this vector implementation, as well as max bandwidth throughput of this implementation. And then this will basically be as good as it can get. Like, I think this is the best architecture. Each env will just run its own get action. They all do CUDA ops. No, that's a ton of tiny operations. You want a relatively small number of threads compared to the number of envs you have. Env runs its own get action. And they're also, you got to remember, they're writing to the same stored memory. So you're not going to .CUDA each observation independently, right? That's a tiny little transfer. You're going to transfer to CUDA in bigger blocks. Number of threads equals number of cores. I think it can be 2 times number of cores in C. I think that the num cores limitation is a Python thing. But yeah, roughly, All right, so the first thing we're going to have to do, we're going to remove num running threads, and we're going to have work tasks. Yeah, we can compare for sure. Ooh. That's a problem. Dex. Heh. Obnoxious. Number beat away busy. Waiting wasn't really a problem. Running the environment. Yeah, I need that main thread for something else now, though. So the main thread now, Peru, is going to be used for managing host device host syncs. Let's see if this makes sense. Fetch add. can easily just do mod and remainder, right? Yeah. So we can just do, I think I know how to do this. Brother, explain what you're doing in a simple way with example. Well, there's not really an example because nobody's doing this. What I'm attempting to do, though, is I'm attempting to have something that can simulate a whole bunch of environments on CPU, and I'm trying to come up with a way such that the data transfers that go to the GPU are buffered, so I'm never actually waiting on data being transferred between the CPU and GPU. And this involves a mess of threading. Hang on, I have to figure out this one thing first, which is how we do indexing. I think it's not that bad. I think num ends, right? Yeah, hang on. We can just do int num ends. Okay, so work index, work task. So I think we can view like this. Work tasks. Work index. Yeah, so the way that this is gonna work, this is gonna be kind of weird. You wait for this mutex, right? And then fetch sub explicit. So we want to do, can review one time your code base. Yes, it's just I'm in the middle of a pretty fancy operation. I've tried to explain it various times today. So the thing is that we have a whole bunch of like remote environments, and these are simulated on a bunch of threads in C. And we have a model that is going to be consuming data from these. But the model's on the GPU and the environments are on the CPU. So what needs to happen is observations come from here, they go from CPU to GPU, and they get to the model. And then the model is going to compute actions, and then it puts them onto CPU from GPU, and it's going to do this with all the environments. Now, the problem is that this is overhead, right? This data transfer is overhead. So what I'm trying to do basically is split all the environments I have up into a bunch of blocks, right? These are 3 blocks. And the idea is that the model can submit actions, but not actually wait for them to be synchronized to the CPU. And it can like go through all 3 blocks. And in the background, these actions are going to be being synchronized and the environments are going to be being stepped. So by the time you get from the end and go back to the start, then the idea is that you already have observations waiting for you on the GPU, and you don't have to spend time transferring. Yes, this is like the send receive, Tim. It's not just doing it at a lower level, though, because the Python multiprocessing doesn't have a way to also sync to CUDA. So pretty much the Python vec just gets you the obs on the main thread in CPU. This is going to have them already in CUDA for you, already on the GPU. So that's why this is going to be way better. It's not just like C versus Python. Way better. Should be, at least. I think that this should get us close to, like, this should get us pretty close to max transfer speeds. This is like probably the most substantial perf optimization we can do. Kind of tricky though. So the thing that I think I need to do with this work index, yeah. Index. So it's going to be -1 for the task. Yeah, I think. And then we have. Ah, complicated. Chess is tough? Yes, it is. But Roger, the benefit here, right, is we can train millions of steps per second. Not really potential. They're all dumb models. But what I'm trying to do right now is we need to keep track of 2 atomic indices. So let me think if I can do this. If I were to write this without this being thread based, let's try this. So we do env and int equals work index, and then we just int tasks remaining equals work index divided by something like this, right? And then we would do new n index equals +1% m's, and then tasks. It's something like this, right? And then int new work index equals like this, right? If it's 1500 elo, it's better than I am. With no search. Yeah, so welcome to everybody. What we're doing at the moment is we're doing the C backend for environment vectorization, and we're doing it with buffered CUDA device transfers. So this is going to be like dramatically faster than any vectorization backend ever done for RL, including my own already state-of-the-art one for Pufferlib. So this should be a pretty big gain. And if you're new around here, it's all open source on puffer.ai. Feed the Puffer star, helps me out a ton. So the problem is, like, how do you do this? Like, this is not atomic at all. You do this, man? Like, Okay, maybe I'm going about this wrong. So all we need to do, we need to know how many tasks are remaining, and we need to know the current env index, right? Oh, let me think if this architecture even makes sense, because, hang on. You submit multiple work orders. I think, no, this still works. Yeah, the design is still good. We just need to figure out how to do this, this operation atomic. Work index. Right, because this one didn't have to be circular before, right? Have to be circular? Let me think about that. Kind of need two indices, yeah? That's hard. Yeah, this doesn't let you update it uneasily. Hang on, maybe there is a way to do it with one index, let me think. I think that you can do it with an end index. Yeah, I think you can do it with an end index and a current work index. Something like Pufferlib when I was 20, very easy. Honestly, if I had Pufferlib when I was 20, I probably could have convinced OpenAI to keep doing all the RL stuff they were doing. Took an extra 8 years. Oh, you just count up, I see. Wraps cleanly after 2 to the 32. So you want u int. Alright, I have an idea. This was fine. Atomic uint. Okay. This is what we're gonna do. So this just counts up. Okay, I know how we're gonna do it now. That was a little difficult to think about, but I think this is gonna make sense. And index like this. Ooh, this one's still race conditioning, isn't it? Now let's try this first. M's. Step. Less than. Yeah, because this is gonna change. Let me think how we do this then. Oh, we just add the same bloody check here. So we fetch env index like this. And this, right? I think something like this is about it. You don't need this. And you do not need We're gonna get rid of this for now, I think. Okay. Okay, so now this is making a thread manager. Arg. Okay. I'm having so much more fun doing this, though, than the stuff I was working on yesterday. Like, oh my gosh, this is so much better. This is, like, actually cool. It's tough, but it's actually cool. I mean, this is, like... This is gonna end up being a 200-line piece of code that just smokes everything perf-wise in RL. Actually is gonna just smoke everything. Jax not have this? They sidestep it by writing their M's on GPUs, so they go, oh look, the GPUs are always loaded, but then they're using the GPUs in, like, the least efficient way possible. The result is garbage. Garbage. Okay, so we unlock a manager. We add this. None of these mess with end index, actually. Actually, literally nothing is messing with this. This doesn't need to be an atomic. Right? Yeah. Yeah, we'll leave it. I'm not entirely sure. Stop hitting my windows, you birds. I put something so they stop freaking, like, running into it super hard, but they still, like... Okay. You can do something like this, right? And then you have to wake. The broadcast. And you just say wakey wakey. But this is not enough. Yeah, I actually don't think this is right. Okay, so this is gonna be, I think this chunk. Get rid of this. Yeah, so this chunk is fine, right? You do an async copy. Oh, and then... do I need an inbox and outbox type thing? way easier to do hang on. Literally, there are 0 1 mil plus FPS. Code base is clean. Alright, like none of these are this fast. Nice try. Let me think if there's a clever way to do this or not. So it's like there's a stream that's going to be used to send actions to the GPU, or to the CPU rather. I can probably, let's try it with one stream for now. Very cool. So this is when we do this chunk, right? Wow. Yeah, now we need to know when these are done. Observations already on GPU. No. Then now this is where we can copy. Yes, we're getting closer. This is where we copy this. See? Let's actually take all of this. Like I said, we'll get harder before it gets easier. All right. So and now it's actually quite easy because now it's just manager outbox. It's like vec send. Yeah, this is all vec send has to do. And now all vec receive has to do is well, it has to fucking busy wait now, which is obnoxious. So this is all it has to do. To do single stream wires. Okay, so this actually becomes very simple. And now the only, other than obviously debugging this mess, the main problem we have not solved the only problem we haven't solved is knowing when our obs are ready on CPU. Let me think about that. Let's just make this a little easier on ourselves. So actions ready. Now let's see what that gets us. So the actions are ready on GPU, and where this is on CPU, then actions are ready on the GPU, and we launch the new job. And if obs are ready on the CPU, then we copy them back. They're all async. How is one stream going to avoid the wait? What? Are you only working with to-dos? I don't know what that means, dude. Okay, so yeah, the only thing we don't have, right, is we need to know when, yeah, this ob's ready on CPU. Ugh. How do we know when that's done? Oh, you know what? I bet we can actually do this as an atomic fetch on work index. Yeah, we totally can. How are you managing your product? Do you have some Trello, Jira? Nope. That's all bloat, dude. There's like no reason to do that shit. Literally on any given day, I just like I pick whichever of the top 3 or 5 most important things there are to work on, and like whichever of those seems most interesting to me is what I work on. It's kind of that simple. Yeah, it's always fun. Oh, was there an RL thing I just missed? I think it was Lucas Bayer. What? Wait, does this dude even do RL? Oh no, this is actually fine when I reread it. Okay, so the thing that I was gonna do here, hang on. End index. Ugh. Okay, this is a simple check, but I have to not make a mess of it. How do you understand the limits of RL? Now theory. Do you understand the gap between the theory and practice of RL right now? The theory of RL basically gives you nothing. And we are like so far ahead of that. The thing, as to how do you make progress, the academic approach has basically done nothing for the last decade. In fact, it was so incredibly ineffective that the academia basically managed to kill their entire field. And now everybody does language models, even though RL is awesome and can solve so much stuff, because mostly academic myopia. I have articles on this. The reason that RL is making progress now is not because of any new improvements to theory whatsoever. It's because I made RL 1,000 times faster, so we can run Google scale experiments at home. And we can just extensively validate whatever we want instantly, or like almost instantly. And that lets us do actually good science, whereas the vast majority of published research in RL is wrong. That's the actual way progress is being made now. I mean, one doesn't invalidate the other. Well, I mean, it depends, right? Like, you can do good work in academia, but like, RL as a whole, how many papers do you see with, like, really simple problems trained for very few steps, with very fancy algorithms and no hyperparameter sweeps and really weak baselines. Like almost every paper. By comparison, right, by default with what we're doing, and you can use our stuff in academic research, you have a ton of environments. They get to be way harder than most of what's being used in academic research. You can train them for hundreds of millions of steps in minutes on one GPU, and you can run automated hyperparameter sweeps with a state-of-the-art hyperparam optimization algorithm to ensure that you actually have optimal settings for both your algorithm and the baseline. So which of these two, like, which starting point is going to produce more accurate results, right? You can still do tons of basic science and stuff, but academia has ignored performance so much that they have basically made it impossible to do quality science. That's the main thing that killed the field. And a lot of it was like focus on sample efficiency over everything else. The experiments just got slower and slower and slower over time. Like you can literally track this. We had, you know, like a few thousand step per second training in 2017 or whatever, and then it literally got down to 200 step per second training in a lot of this stuff that was in like 2022 or 3. But should have been getting way faster. I mean, the amount of things I've seen that are just like pure engineering fails, where you prevent yourself from doing any quality science because you failed at engineering so hard, it's just everywhere, right? And the problem, Hyper, so the reason that I say it's like academia killed their own field is because it's baked into the review system at this point. Like the reviewers are so entrenched in this like high sample efficiency, screw all engineering, like these classic set of super slow, unusable baseline M's, and like it's just a mess. So it's almost impossible to publish the type of stuff that is actually needed to fix the field. So incentives are powerful, the field just dies. And most of the people that I know that used to work in RL, you know, back in 2018, 2019, who were really good, they got fed up with it and they moved on to work on language models because it was hard, brutal, thankless work. You publish papers where you improve speed instead of accuracy. Nope, you can't. I tried this with Pufferlib when Pufferlib was 10 times faster than everything else. When Pufferlib was 100 times faster than everything else, double rejected. I had to make Pufferlib 1,000 times faster than everything else before it would get accepted. So think about that. You can publish a paper where you show our algorithm is 20% better than their algorithm, and it gets published on like some stupid benchmark that doesn't even transfer to anything else. But if you try to say, hey, we made all of RL 10 times faster, you can't get that published. How fucked up is that? Like, the mindset of the field is just so wrong. Theory outside of the norms has the same problem. Well, that's ridiculous, right? Academia is supposed to be the place for new ideas, but it really isn't. And that's one of the things that I had to learn. Like, literally, you get punished for going too far outside the norms in academia. So, like, an industry doesn't have the risk appetite to, like, do crazy things most of the time. So pretty much you just have to do your own stuff outside of either of those with no external pressures, or stuff doesn't get done. You got best paper award. I got best paper award, Hyper, but this was after, like, basically fighting the system for 7 years, really not getting much recognition on any of my stuff for any of the engineering, any of the like large-scale multi-agent stuff I did for years, and then pretty much devoting a year and a half of my life solid, essentially doing nothing else, like working out and writing this stuff, 1000xing it. Like the amount that you have to pass the existing by in order to get there is just completely unreasonable. And then, you know, you can go to the same conferences and you can just walk by the row of papers, and I can just, like, at a glance tell you, you know, those results are not going to be better than random on, like, 9 out of 10 of the papers. It's a mess. Academia is a mess. But it's fine because, I can build tools that will help with research. It's just like, I'm no longer gated by having to publish stuff. So, that's fine by me. Raving JMLR reviews. Practical stuff. Yeah. I mean, that's pretty much the long and the short of it, right? Like, there were actually several pretty damn good projects on, like, infra side back in the day, and they just didn't get any recognition. So the authors left. I know one of them's at Minstrel now, having fun doing engineering on language models because, the RL community were a bunch of tools and didn't appreciate his, like, awesome eng work. That's how it is. Hey, Lewis. We are working on the C vectorization backend with async CUDA buffering. We're trying to do async buffering host to device, device host. This will be a very, very big speed enhancement if I can get it to work. Okay, so yes, the thing that I was thinking about here before I went on that giant tirade, RL equal language. Yeah, exactly. It's dumb. It's fine. We'll have the field like well where it should be within a year or two. Ninsky is doing some cool stuff. I know. I collaborate with them. We ported their drive env to Puffer and made it 15 times faster. Work index and index. I'm trying to think what we do with this. It's very close. I need to do it's some check on the end index. FBR, academia will do the opposite. They will spend 1,000 times the wall clock time to solve it in like half the number of steps. Like, the wall clock time thing is an invention of Pufferlib. Isn't that crazy? Like, basically, nobody was even looking at wall clock. Welcome everybody. Hang on. This is gonna get boring quick if I don't figure out this indexing, so let me figure this out real quick. I just have to check. All I have to do is come up with a way to figure out if the observations on CPU buffer is actually ready or not. Obs ready on CPU. Okay, so this is actually not. Yeah, so this is wrong. So this should be if comic theoretical innovation over engineering. Yeah, but the thing is they hard bottlenecked on engineering to the point that they couldn't make any progress anywhere else. Like, literally, the vast majority of RL published papers are just wrong. The results are invalid. Almost 5K on YouTube. That's cool. We're almost to 25K on X. So it's gonna be start index. Ugh, this is kind of gross, isn't it? I don't have any good way to get this index, actually, the way that I have it like this. Oh, no, I do. I do. Oh, yeah, I totally do. And, like, there's one of them I don't have to loop over. We do not make brain rot garbage. Chart index. I think it's something like this. Something like this. Just do Okay, it's something like this. Let's now I'm gonna go through this and we're gonna figure out whether I think I've done this correctly, and then we're gonna see if I can get some of this debugged. Yeah. That'll be the goal. I'm gonna use the restroom real quick. I'm gonna see if I can get maybe another set of 3 in on the deadlifts, maybe. And we will continue. That work index run indefinitely. Yeah, I think the goal here, Daniel, is it should loop. It's a uint, and we're gonna have it so that it loops back around safely to 0. I think that's gonna be the goal. But it's kind of a tricky design. I'm gonna have to go through it a couple times. I'll be right back, folks. And then we'll see how far we get on this. I think if we can get something that is runnable today, I will be very happy. That'll be tricky, but we might be able to do it. And like as soon as I have this, it's gonna be. First of all, it's gonna be way faster, and second of all, it's gonna be really easy to test exactly how fast it is. We'll make like a little C test env that has one-dimensional obs for like pure throughput, and then we'll make one that has really big obs for pure bandwidth. Right back. Okay. Now we go over the logic of this, and we shall see what I have here. So, the design of this thing is you have a big bank of threads for running the environments. They're threads, not processes, so they kind of just like each thread just grabs the next environment that needs to be processed and processes it, all in the same shared memory. So no stacking, no copies. Probably will make it each thread process its a block of environments later. But for now, this is good. And yeah, for now, this is totally good. And then there is a main thread. Well, there's a main like work thread, not the main thread. And then that thread is responsible for when you give it actions and you do an async transfer to CPU, you take GPU actions and async transfer them to CPU, it will check when that is done. And when that is done, it will tell the worker threads that they can start processing that block of environments. And when that block of environments is done, it will initiate the asynchronous observations to GPU transfer. That is the job of that thread. And that is pretty much the entire architecture. So let's see if we've done what I just described correctly. We have C thread step. This thing is going to lock on this wake mutex. And yeah, there's a work index and an end index. So when it wakes up, it reads the current end index, which is fine, because you're going to not wake these up until you've set this. And you're going to set this explicitly or atomically. And then what it will do is it will add 1 to the work index until it gets to end. This is the key that we filter. And it will step this env. And then it goes back to sleep. And technically, if we wanted this whole thing to busy wait and not have to lock at all, we could just delete this, and this could just be while 1. Right? Cool. Now, the thread manager, on the other hand, the thread manager loops forever, and it goes over all the buffers, and it says if we have actions ready on the GPU, which is very easy to set this flag, and CUDA stream query, and the stream is not blocking. So that means that the actions are ready on the CPU, right? Then we are going to say that the new endpoint is going to be equal to the end index plus the block size % with the number of m's. And we broadcast that. And is this compatible? Fetch work index less than end. Actually, not a huge fan of how this is, because this wraps weirdly. Okay, so that we're gonna have to come look at that. I think pretty much everything that's screwy is in this thread manager. But you do set the end index, and then this is in the correct order. And then what we do is we load up the current work index, and we say, hey, if the current work index is, if it's gone one full block, then we can increment the start index by a block. And this relies on the fact that the M's are always processed in order. So this is valid. I think this has to be initialized, but otherwise this is valid. In fact, let's just do that now. It's calloc, so it's totally fine. And then we say obs are ready on CPU, which is true. Starts buffer block size. And then we're going to async copy them over. And then on send, all that send does is instantiate this copy and set this flag to true. Actions ready on GPU. Actions ready on GPU. We should set this to false. They're no longer ready. Okay. And then on receive, all we do is if the obs are not ready on the CPU, we need to set this one, right? So we just do obs ready on CPU of buff is true. And then this one, obs ready on CPU is false. Cool. This is roughly the correct design. Because now there's a couple places here. There are a couple places we're still busy waiting, which is awkward. But it's only in the main thread. The main work thread. Like all the other workers, they never busy wait. So let's go fix a couple very minor things. And we should be able to like actually try to run this in a second. See. Buffer. One is fine. Oh, right. The one thing we didn't fix is the end index. Let me think about the end index first. So this is how we decide whether the environments are done processing their block, their chunk of M's. The easiest thing to do here would just be to use an int64 and then never worry about it, right? Why don't we just do that? Let's just use an int64 and never worry about it. What's the C for atomic U64? Atomic UInt64T. 4T. Okay. 4T. And this is uint long, right? Sign. Okay. Atomic uint64. And this will be quite good. Oops, what happened here? Definitely want these. And what we will do, what we shall do with this index atomic fetch explicit be percent this. So now we no longer have to worry about all this like circular stuff. It's just pretty easy. Should be at least. And then the next thing is and add block size. And that's easy. We'll star this. And what's this buffer? Buff. And that should be most of the errors. Unknown type atomic uint64t. Can we not use that? The atomic types. I can just do long. Doesn't have to be unsigned. Okay. Atomic add explicit. Too few. CUDA mem copy async. Find. So what we do, source, dest, count, kind, and stream. Ah, yes, we need this stream. That's totally fine. Buff. Work. Let's try this. Obs ready on CPU. Yes, apparently I missed a curly brace. C thread manager. Job stupid autocorrect. Incompatible types. C thread manager takes void star arg. Static. Null C thread step void star vec. Really? Passing void star. Huh? C thread manager, C thread step. Static void star. Okay, choose. There we are. That's pretty cool. Now, of course, I don't expect this to run. And apparently, we have CUDA crashed. Docker stop. Gotta reboot the Docker container real quick. And of course, this is going to deadlock somewhere. Alright, so now we're going to figure out how we debug this. This is, annoyingly, this is threaded code. So I hate debugging with just basic prints, but I think that's actually going to be... I think for threaded stuff, that's going to be like the first level basic thing that we do. Especially with this amount of threading. threads. Okay. All right. Interesting. The only print we get. Let's go turn off verbose. Turn this off. There we go. So waiting for work. All right, so what we got is waiting. Okay, so all of our threads started up. They're waiting for work. We created 8 threads. We created the backend. Thread manager starts. Thread. And nobody ever gets assigned any work. Observations ready on CPU needs to start out true, I believe. Might be ready for the big run. Oh. Let me know, man. It's not that expensive to be running these, so don't worry if it takes a few. The main thing that would save me time, Jess, is if we get a clean PR into Puffer 4. And I won't run it with this janky C++. Like, the Python is stable, right, in Puffer 4. So if we can run it with, like, the, what is it, Python pufferl in Puffer 4, and have the config work out of the box, then, like, a-okay, especially if you can know that it like doesn't crash crash multi GPU or anything, and we can set that all up for you. That's the main thing. Okay, look at this. Way better, right? Waiting for obs on CPU. Okay, so this is going to be vec receive. Cool. Ah. Oddly annoying. Fighter branch is self-play. Find Fool's Mate and defend. That's cool. Very cool. I'm quite excited for all the self-play stuff. I've kind of left that to Spencer and you, and I've just been fighting CUDA demons and vec demons and all sorts of low-level demons, man. All sorts of low-level demons. Demons. Yeah, I don't like this, but we're gonna do this. Honestly, just do it right once and be done. Back reset. No. Single GPU? No, we do multi-GPU. I'm gonna have to modify this when we do multi-GPU with this specific version. But not by much. Ocean and CMs? Yeah, this will be only Ocean and CMs for this backend. I mean, this is basically the nuclear option. Pretty. I've been planning to watch it. I'm gonna watch it on stream soon. I got kind of tied up on this today, though. I'm frankly shocked that that still trains. I guess I do only have one buffer, but like still. Hello, Bet. How buffered are we? About as buffered as a puffer. Alright, so this one break, yeah. But no wonder this one breaks. Yeah, so now we have to modify this chunk of the code. Yeah, so now it's going to be a slight change to this C++ as well. Huh. That's funny. Okay. Trying to think how I want to do this. fuel. No longer needed. This is going to be obs batch narrow. And block size. Buff size. Batch. It's all fine. And log prob. CUDA. It's a little awkward, isn't it? What rewards? Log prob is the same, but then reward buffer is different. Oops. Yeah, that's super gross. Value. Okay. This is no longer Actions.copy. Joseph's. Who is on Joseph's stream? What? Do you submit any puffer stuff to iClear? Nope. I don't really publish much anymore. Kind of hard to do that and all the open source work. The state, right? Crazy obnoxious architecture. Go explore will be huge. Yeah. Have something interesting. Success. Training on the random legalized position. Help. You can try all sorts of stuff like that. I have to go for dinner fairly soon. I'm just gonna see if I can get something that compiles. Oh, I just saw your plot. That's awesome, Jess. The real ELO plots? That's awesome. Hey, Kyung. You just dropping by or you got some stuff to show? Because I'm going to dinner in like 10-15 minutes. Honestly, this work has been exhausting. This one's pretty cool. Like, we're making good progress on this, and I can tell this is going to be awesome when it's done, but it's complicated. Definitely complicated. Sweep seems ready for merge. I thought I merged Sweep. What new stuff is there in Sweep? Yeah. Yeah, I'm just getting towards the end of this work block, man. It's just been like a lot of stuff for a lot of weeks. I'm trying to at least get Vec done, though, before I need to really take a bunch of time. Go. What's left for Puffer 4? I mean, Vec, Optimize Mingrew, Polish Constellation, all the experiments. There's no way I'm getting it done this year. It was too optimistic. I mean, even if I like work myself 24/7, but it's fine. Like we're still making good progress, and like nothing is going wrong. It's just hard, right? We'll just make if Puffer 4 takes like longer than the normal 6 months, Puffer 5 will just be a smaller, more concentrated update on Go Explore. Most likely the case. The folks have been watching. We actually had a ton of people today. I am gonna go get dinner in a few. Tomorrow we have a special stream. I'm gonna be trying out TinyGrad, and we're gonna see whether it's actually the high perf miracle that is claimed, and whether it can do useful stuff for our kernels. That sounds interesting too. All of my stuff is free and open source right here. The only way I make money is off of companies. We do custom high perf sims and such, custom RL. But all of Pufferlib's open source. If you want to help me out for absolutely free, Feed this puffer fish a star. He likes stars. Helps me out a ton. And if you want to get involved with development, whether that's research side or just like jam some low-level game dev and still contribute to science, Discord is here. And other than that, I'm on X. You can find me here, all my content, including educational stuff. Are you going to watch the interview tonight? Jess, I think I'm going to crash and try to get a good day in tomorrow with TinyGrad and stuff. I said I will do the podcast live at some point. So I'll do that, and I'll probably post it to YouTube as well. For 3 code will work with 4 and 5. Yeah, so there's going to be a Python backend that's basically the same as the current one, just with some new architectures and some perf enhancements, plus Constellation. So like new tools, new sweeps, new visualization stuff, speed enhancements, new architecture. And that's going to be all like simple Python. And then if you really want max perf, right, you can run the C++ backend. That's going to be the idea. Ah. I got a couple minutes. Double check. Nope. Thing. Quick check on Neural MMO here. Still going. Doing endgames now? Yo, that's pretty cool, Jess. So 6 GPU makes basically you get 6x the batch size in about the same amount of time. We finalized sweeps. Bit late, Kyung. I can review the PR on stream at some point, either tomorrow or Friday. We did everything that you did before, like from the last couple days. Everything is merged into 3 and to 4. Your Gelu fix worked? What Gelu fix? Oh, yo, Convert, did you have a Gelu bug in the C++ nets or the C network? Because that was a bug in some version that we fixed that. There was like a very small discrepancy. Yeah, Convert, that was a bug that we patched. So if you had like an old version or whatever, there was in fact a bug. The Kyung's fix worked. Did you get our? Because I wrote a patch for that. I think it's in 3.0. It's definitely in 4.0. You can just look the change history on that file. Ah. It's Joseph's commit, yeah. My bad on that. That was a really dumb bug. That was like totally my screw up. It screwed up the GPU drive evals as well. I had to fix that a while back. Downloading maps was hassle. Yeah, drive is a little bit of a hassle, Kyung, and they have new versions and stuff. I'm chatting with after NeurIPS, I've got some stuff planned with their lab anyways. We'll make sure though before that we get full 4.0 in that we crush their we crush whatever their latest model is with 4.0. Bufferlib 4, the fastest ever RL. Hangs, but at least it runs. Cool. Here we are. 150/80. What, Jess? GTX 950. Yeah. I mean, like, we have all these boxes up here. You know, these are for contributors. If you're building stuff, like, we give people SSH access to these boxes. If you're building something cool. Actually, if anybody wants to just go through the Discord and see who's using what boxes, because I'm sure that there are people who are no longer using their boxes. You know, so we can like reallocate stuff. Because like Jess, you probably should have a box by now. Right? FBR would have a box if he ever PR'd any of his cool stuff. Yeah. I'm box 1. Yeah, I know you're using box 1. Hey, Spencer. Yo, Spencer, we're gonna absolutely the new news is we're gonna absolutely crush vectorization. It's just gonna take some work. I gotta go for dinner in a minute, but we're gonna be able to buffer the async buffer all of the CUDA transfers. So we're gonna pretty much be able to eliminate. I think we're gonna be able to almost eliminate CPU GPU transfer overhead, which is like the majority of the entire eval loop right now. That's the latest news. Okay, so box 2 is, I forget who's on box 2. And then we also have 5, 6, and 7. Cleaning up rocket lander and redoing physics. PR one of the M's, man. PR a cool M for access. With good clean code. Fun results. Self-trust. Yeah, I've seen. It's pretty cool. I'm gonna go get some dinner and get some rest. Tomorrow is the Tiny Grad stream, so I'm gonna be live with that all day tomorrow, pretty much. Like, good. I don't know, at least 5, 6 hour stream on that. And then we will probably resume this stuff that I'm doing here on Friday. I think that nothing would change that. Like, even if TinyGrad is awesome, we're still going to need Vec. So, and the Vec is going to want to be CUDA. So, yeah. Anyways, see you all. Have a nice evening. And tomorrow is Thanksgiving, so happy Thanksgiving. Bye.
Integration test passes, then I don't have to worry too much about the... Ooh, you need to set your default editor. Go into settings. At the bottom. Yeah, there you go. Yeah, set your default editor to whatever you want to use. Yeah, there you go.
Oh, I didn't know. Okay.
Yeah, cool. Okay, so what is this actually going to do? Client.generate title. Can you click into client.generate title?
Well, we can just look at the results, right?
I just want to make sure that that's the right function. Yeah, this is the one we wrote. Okay, cool. Sick. Okay, and let's look at the test cases. Query generated title, and it's just doing basic sanity checks. So let's go look at the test output and look at the logs, because it's just logging the stuff and then doing like a sanity
Where's
check.
the test output?
So if you go into the code layer session, you can see where it ran that test. Nice. All right, yeah, this looks pretty good. Okay, this was one of the bigger unknowns for me, so I'm glad we got this working. Let's tell it we're good, and we can proceed to phase 2.
Didn't have any of the... Oh, okay, cool.
It's just did it into tail, so.
Phase 2.
Yep, let's do it. Yeah, because we can always come back and mess with the prompting. I just want to make sure this is wired all the way through. This is like vertical slices. Get it, like, you should be sprinting to as quickly as possible, get to wired all the way through.
That's interesting. I think it's interesting. We developed it very differently, I think, in our repos.
Yeah. Well, this is why we hang out and swap ideas and learn things from each other. That's the goal of the show, right?
Yeah. What we end up doing is we actually just focus on building a really good test harness where we can add more tests incrementally.
Yeah.
And then just focus on getting each layer perfectly correct and then work through to the end.
Yeah.
That's what I found.
Red, green, refactor, iterate, right? TDD. Huh? Yeah.
Red, green. Sorry, I don't know what that is.
TDD is like you write the red test and then you make it green and then you refactor it and you keep it green.
Yeah, exactly. And then I found, well, I've also found, like, in general, like, just for example, like making it work from like the very backend layer is, at least in our repo, it's very hard to make it work all the way end to end and just get summing plumbed all the way through.
Yeah.
So we just try and make it so like the right data is present as much as possible in each layer, and then just test each layer individually.
Yep. Okay, cool. Let's just scroll down. This looks fine. Obsidian open path equals. That's what we were doing? I don't think that's right. I think the format was just...
It just requires you to have a vault. That's all it is. That's a URI.
No, but wasn't the command you were running was very different?
No.
Go in your terminal. You were opening Obsidian and it's just the path.
We also have the app thing that we were doing before, right?
I would just give it that feedback. I don't know if that also works. I mean, you could try it, but...
Also, where'd it go? What is it called? Also, we want to use app.opener. Oh, this. We told it to do this.
Well, it decided that that's the thing. I don't know if it hallucinated this or if this also works. You can try. We can test it. If you go to your terminal, just try doing the open with that path.
Yeah, that's true.
So it's open # path equals.
Yeah, it
okay. That's fine. All right, we'll do that. Cool. So let's keep reading the plan then. Cool. Updating file link.
I just know if it's a markdown file.
Wait a minute. Scroll down. Yeah, this is wrong because it's like it should be open in. So look at how it does the editor stuff.
Where?
So scroll down a little bit. So editor is get preferred editor.
Yeah.
And then it does invoke open in editor with the path and the editor.
Mm-hmm.
The other one, if you scroll up, it's calling a special function called open in, no, down, like literally in that same function, like 5 lines up. It's doing get preferred markdown editor, and then it's like if the markdown file is this and the markdown editor is Obsidian, then we do open in Obsidian. Oh, I see. Okay, it's trying to be clever. I mean, this code is ugly, but it's technically like slightly less code to write because it's just doing if it's Obsidian, then we just open in Obsidian. Otherwise, we fall through and open it in your editor.
Yep.
I'm fine with this. It's not beautiful, but it's.
What do you want it to do? Propose alternative.
I was thinking that it would like match. There's basically like we always calling open in editor, and the Rust side of it because this is calling like invoking a Rust function from the front end. I would prefer if open in editor just handles like the markdown logic on the back end.
Okay, let's just do that.
Okay.
I mean, that's the good thing about vibe coding.
Yeah,
It's
yeah.
not hurting my feelings, right? Like the model doesn't care.
Yeah. So it's like I'd prefer if the markdown splitting happens in.
I'd prefer if the
Rust.
markdown splitting was happening in the open and editor capability rather than in the logic ahead of in front of this function. Before this function. Yes.
Cool. All right, let's keep reading while it's fixing that. I personally take everything my model does personally. Okay. Yeah, because then we have that block duplicated in this function too, which is annoying. Cool. And then settings UI. Did we add a database column for this setting, or is it just in local storage? Oh, I think it's because the preferred editor is in local storage. It's not in the. It's not
Yep.
in the. It's not in the database. Fuck. All right, fine. Just leave it as is. So this one's still implementing phase 2. Let's go back to the Obsidian one. Let's just keep this how it is. That's fine. I will go back and refactor this to use settings later.
I think it should be really easy for it to do. Oh, because you need the database?
Oh, no. It can just fetch it and then send it in the endpoint. Yeah.
Yeah.
Yeah. Okay, we just send them both. Open an editor has a new thing called Markdown Editor. Yeah, that's much better. Fuck yeah. Okay, cool. Yeah, this is going to work.
Cool. Let's go read this.
Cool. We already read this. Yeah, we've been
Nope,
through this.
you made a whole new thing.
Okay, cool.
It updated. You can't.
Yeah. Okay. So it takes editor and markdown editor. Yep. Okay. So is markdown.
Right. Then it has a way for Obsidian. Otherwise, it just does it that way.
Yeah, I'm okay. This could be factored a little more nicely, but I'm happy with this. This keeps all that like logics like kind of isolated to one place that's testable.
Cool. Should I do it?
Yeah, let's let it rip.
Okay. I don't think we need phase implementation for this. I'm just gonna
Do phased implementation. It's just better.
But there's
You just want to
no
give
phases.
yourself. It's the same reason why you use a bigger model, even though you might want to use a smaller one.
CL implement plan.
Fine.
Just trust me.
All right. Vibes. I trust
I
you, buddy.
I think a lot of what a lot of people underestimate is just like I said, this is something
Yeah.
I say a lot. Like a lot of people start locking in their perspective of the model way too fast.
Yeah, you gotta binary search on either side and like
Yeah,
try things that
like-
you really think won't work and see because that's how you learn. What
Yeah,
the
like
boundaries are.
I suspect that you're like, hey, we need phase implementation. We're like looking at this, I'm like, no, you probably don't. Like my personal opinion says like, and even if I don't, worst case, I waste like 5 minutes or a couple 1,000 tokens,
But, like-
and I just redo it.
Phased implement, you can just tell it like do every single phase in a row. Don't wait for my input. And the only difference is you're doing the exact same work, but you're using smaller context windows to do the work. You're in the work tree, dude.
Oh shit.
Yeah. So you'll have
This
to go do that work tree thing again, or
God.
go to the one where you made the work tree and be like, make another one for this thing.
No, I'm just not gonna do it in the work tree.
All right. You're so confident.
I think this is the other thing that I really want. Like in any coding editor, I want it to detect when I'm making mistakes like that. To be honest,
Yep. No, I mean that's
like that's
being
what actually makes this stuff really good. Like this, like part
well,
of
I
the
mean
reason.
giving you a first class like you hit Command K implement and it like looks at the plan and figures out what it should be, and like having the
So
stuff organized into
I will.
tasks and projects is a big part of that too. Is
One of the
like
things
just
that I
like
would push back on that is like I
yeah
think while that is kind of interesting, what I really want is just like I
yeah
just want it to catch mistakes for me. And like if it's the more opinionated it is and how I do my work, the harder it is as a developer to really abide by it 100% of the time. Because as a
that's the
developer, I
trade-off.
kind
There's
of
other tools that like really do all the work tree shit for you, but they also bring a lot of opinions, which like for me some of my like friction there was like I don't like how opinionated this is, and I want something a little more like I want to be able to decompose it. And the goal is like first experience it does it all for you, but then you can decompose it into building blocks and get more flexibility as you grow.
kind of. So maybe I can show you a couple of things that at least I'll show you that I have found interesting now. So like what I
Yeah.
have found is like this tool is freaking dumb, to be honest. But like whenever I actually create a plan now, what I actually do is I'll show you exactly what I do. Like let's say I was doing, uh,
But this is reads your Claude commands now.
yeah,
Spicy.
exactly. Um, but I'll show you like exactly what I would have done from scratch if I were doing this. Uh, like what I actually do is whenever I create plans, I actually do this. CL, like research code base. I'd say something
Yeah.
like figure out how I can add AI generated summaries. And I just like swap it on like this. And this
Okay.
has been
Oh, and then you do like four in parallel.
exactly. And I don't even care. Just go read at the end because it's just saving me a bunch of time, right? Like, and this GPT codex is so dumb. I hate codex. And now that it's doing this, it doesn't really even matter what model I'm using, to be honest, because I'm not tied to a model. I'm not tied to anything else. But like the ability to like multiplex is
Yeah.
super useful. And what I have found, at least for a lot of our code bases, is rather than focus on getting this one prompt really right, what I let it do is I let like 3 or 4 models produce similar outputs, and then based on what the models produce, because it's way faster than me going down to this is. Then what I do is I just read this thing, and this I hate, so I actually end up reading this in Obsidian. And the
Yeah.
way I do that is I have to do some stupid process of like syncing this back. So what do I have to do? I have to like accept this thing. Where'd it go? Where's the
Yeah,
generate
this is
to?
the funny thing too, is like it's the like cursor UX is for like code changes that matter versus like if you're just dumping a markdown doc, like we don't use work trees for that. We don't really feel that you need like it's just like you're doing it's like a write
Well,
only like
the
single new
minute I
artifacts
start doing stuff in parallel, it's actually super useful.
to have if you're editing code, but if you're just dumping out new research documents, I'm like I don't know if
Even
you
in
need
that
this
scenario,
like
it ends up being
approve.
super useful. And the reason that it ends up being super useful, even in that scenario, is
When you
because
just go ahead.
it will end up over if I have like 2 parallel things, sometimes it'll end up overriding each other with the same name that it generates for the research that it produces.
Oh yeah, that's bad. I mean that's why
Exactly.
you would want yeah.
Work trees. It's more about when I'm multiplexing, right? Because that's really the problem when I end up doing things.
Yeah.
It's easy to have like a single work experience, and like that is the only reason I actually found like it was kind of interesting with multiplexing for like really really complex things because there's just no way. Uh, how do I do this? Okay, I'll just try this. Why not?
Yeah, so you have to go take your running version and actually go like check that out. This is wrong. I will
Oh,
give you the this is the other thing is like we read the plans but we didn't actually this is the thing that everybody does including myself is you like forget to check the like actual testing steps. But I can just help you do this. So you have Sinclair running somewhere. So what you want to do is you want to create a new session and then go make sure that it wrote the new title to the database. Yeah, there we go.
So I'll run this.
Yep.
Yeah, the multiplexing has been super clutch. I really am excited for when you add that in, because I think it'll be super nice to be able to just
When
be
you're
like,
talking
and
about
specifically
multiplexing, you mean like being able to launch multiple sessions with different models?
different models, and then be able to merge them trivially.
I like that. Cool.
Yeah, it's like in this case, like see in this case, it's not too bad.
Yeah.
Where is this? Okay, so this
Cool.
is the thing.
So I'm gonna show you a couple things. Number one, you're not gonna run that command again. You're not gonna run
Okay.
that. So at the bottom there, click on the debug button. Yeah, that one. That's gonna tell you your database path. Yeah. Okay. So at the bottom there, there's a path to your database in the bottom. Debug information path. Yeah. So you're gonna use that as the path instead into SQLite 3. Yeah.
I actually have no one-on-ones today because technically I'm on vacation.
Nice.
That's
what a
another
better way
thing
to
to
spend
talk
your
about.
vacation.
Okay.
Okay, so it's not in there yet.
Welcome back to the deep dive. Today we are going to do a full architectural
was there
teardown
a
of something pretty
migration to
fundamental.
run?
We're looking at the infrastructure that lets...
Can we go read the code layer output instead of just pasting in random commands?
That's a good tips.
No, can we
The
go
KV
see what it
cache.
said to do?
Yeah.
'Cause it
Instead
might
of
have had you,
recomputing
run
the
something
KV states for
before
the
you
previous
actually
n
go into
tokens,
this.
we just store them.
Let me pull this up.
launch just streams out word
Okay.
by word.
Okay.
Oh, it wants me to go run the test.
No, so it says those work. It actually, if you scroll up, it actually ran these for
Oh,
you.
yeah.
And then it says start the daemon and verify migration applies cleanly. So you probably have to. Yeah, that's interesting. Can you just do it into grep AI? Or we can go look in the migrations.go and just see if it actually added it.
I mean, I think the
Curious.
title's not here, so it's like I suspect it's not there. It's definitely not
Yeah.
in.
So that's interesting. It's also interesting. Like, can we do something else? Can you, in your bun, can you add one more parameter to your nvars, or just export like build type equals experimental? Because this is actually sharing your prod database for your stable version, and I don't like that.
Build
Type equals experimental semicolon, and then then run it. This should give you like a dev database that is separate.
I think I'm
from
running
the
experimental
main one.
dev build. I would stop.
No, you're running the front end in experimental mode, but not the back end, because it's using your prod database. We also onboarded Fibob into how to run this stuff last night, so some speed bumps perhaps expected. All right, so now if you go into debug, you should have a different database path, and let's try that SQLite again. Not here. Debug. Oh, why is it still using that database? I don't like that.
Is that the right build type?
Yeah, that should be right.
Spelled
What do I have
experimental
in mind?
wrong. I spelled experimental wrong.
Oh, okay, nice.
Yes. I mean, that
That'll
should
do
be
it.
obvious because it loaded a bunch of my prompts. I mean, also,
right, yeah.
like I said, this to me is like so to debug this. Like, clearly the database doesn't have any SQLite, so my hunch says, nope.
Huh.
Maybe we can just look at this code.
Are you sure you spelled it right? Experimental. Well, it's like, I think this code is definitely correct, but the problem is we can't validate it, because when you run the local daemon, it falls back to the one that's already running as part of your like prod instance. When I run this, does it use the prod database?
But why does that matter?
Because I think that, like, if there's already a daemon running for your prod build, it may be basically like, because this migration happens when the Go backend spins up, and so if there's already one running, then it's like not working. Like, I don't want these things competing over the same database. That's the number one thing that I am quite certain is not the right idea. So this is an issue with your dev environment, though, at the core.
Okay. Well, I mean, I have AI generated titles here.
Yeah, it's all coming through.
Do you want me to turn off code layer? Like close it and then run it through developing it?
I don't like that either because, yeah, mine's doing the same thing. Just in your .env set human layer database path.
Okay.
Or just export path equals, yeah, that's fine. Tilde slash dot human layer slash human layer experimental dot db. Just in your .env set human layer database path.
Okay.
Or just export path equals, yeah, that's fine. Tilde slash dot human layer slash human layer experimental dot db.
You want to send me the command?
Yeah, sure. You're not sharing. I'll send it.
We have some questions from people. I'm not screen sharing.
Yeah.
Let me add that.
That I think should work.
And we're getting a bunch of questions from people actually.
People have questions on this show? That's crazy. Can the research agents panel cursor spawn subagents? I don't know. I don't think so. That's a good question. Yeah, it doesn't actually use the subagents, so it probably won't work as well. I'm sure cursor will have subagents in no time. I'm sure it's happening.
I figured out the problem. It's because of work trees, actually. Work trees need an end file that is copied over, and that is not tracked by Git.
Oh, so we did update that script to also copy in your .env file, but I don't know if that got merged yet.
I'll add it to both. Yeah.
Oh, wait, are you running sync layer in the work tree, or are you running it in your main branch? Because that would also do it.
I was running the work tree, but I'll run it again in the work tree. But the work tree definitely did not have end bars. Let me just make sure I'm not going to copy end bars and show them on screen.
Appreciate that.
Yes, we are good.
Okay. Yeah, I tested with the database path, and it is working better now. Yeah, we had this working in the other repo. And
yeah, David, the Go repo is directly in the Bamble repo. You can just, but the Go layer is actually quite thin. So if we want to support the stuff and you have ideas, I would love to take you up on it.
Yeah, today we're working on human layer code, not on Bamble. All right, so you launched it.
What is the command called?
Did you export that?
Yeah.
Did you export it, or did
it's
you
in my .env file.
You just set it? Oh, okay. Cool.
All right, cool. This is running. And again, I think like a lot of people underestimate like should I be running this cursor? Maybe, but I don't have the work tree open in cursor, so it's just not worth it. I think my default behavior as an engineer is I just use the lowest friction task to go do it. So like when it comes to like any sort of coding agent or tool, I always want to just like have it contextualized because it just makes me way faster.
We're putting a terminal in code layer soon, so you can just run it from your code layer session.
Then I might do that, but it's really about contextualizing stuff for me.
Yeah. Yeah, you want to keep everything grouped in the same place.
Yeah, it's the same.
And when you context switch, you want everything to get updated.
Yeah, it's the same reason what I really want is I really just want like freaking like AI chatbot in Obsidian. That'd be freaking sick for me when I'm working on plans.
How about Obsidian in your AI chatbot?
Either way, it doesn't really matter. I just figured it's harder to probably port Obsidian.
Yeah.
Because there's just way more code. And like the UX of editing Obsidian is so fast and it's so nice.
Yeah. Damn, you came around fast on that one. All right, here we go. This one's going to be empty. Amazing. All right, this should have like launched and done the database updates and stuff. So can you, get that path and let's run the SQL. Well, you have to make a session. Well, I guess we can check the schema. Well, you killed it. Yeah, fine.
Oh my god. I hate code. I should really be using Warp.
All right, it's there. Sick. All right, so make a session and then like query that field and then.
Nah, it's probably in there. I don't need to do that.
No, I want to do that. I want to make sure this is working because if it's broken later, I want the confidence that it was working after phase 2. Sorry, dude. This is how it's done.
Well,
I'm sorry we don't have 2 years of incredible test coverage and our problem is in a programming language which is immensely verifiable.
Well, I would say there's different parts of it. Our VS Code extension is not very verifiable. That's actually like the hardest part about our system.
Yeah. Cool. All right, make a session. Don't put a title. Yeah. Amazing. How fast can we do this? So what we should see is...
Oops.
Oh, no.
Nah, I gotta cut the stream. Fuck.
You want to pause it and go delete that key real quick?
Yes, I do.
All right. Sorry, folks. This is the price of live streaming. You want to see this stuff live as it's happening? You gotta wait while we go delete keys that we accidentally leaked.
Yes, that's an urgent task I have to do.
Yes, I'm gonna run through and just answer some questions while you're doing that. Love some visual organizational feature whereby related code layer sessions are grouped together in the main view. Yes, nested under a title. Once we have AI session titles, then we can also have grouping by themes. We can have classification and labeling. I notice I can get super indignant when it confidently does something I later think is obviously stupid. Instead of treating it... Okay. Yeah, I agree. All right, I'm going to go find actual questions instead of comments.
How do I disable a key?
Yes, Max, 100% agree. Yeah, being able to have nested sessions on it. We're actually not going to call them projects because people use projects as like too big. Project just becomes a bucket of stuff.
Yep.
I think the lowest unit of like grouping will probably be a task, because for one linear ticket or one GitHub issue, you will likely have, you know, 1 or 2 researches, 1 or 2 plan sessions, and then 1 or 2 implementation sessions, and that's just to ship one thing. And so that's kind of the idea of how we might also have projects or workspaces or something, but I think the top level, like the lowest like grouping dimension is like more like task than project.
Cool. Let me rerun the stream again, and then we'll be back.
Nice. Sorry about that, dude.
That's fine. The key is now revoked.
Amazing. If you manage to go spend 5 cents on Viva's OpenAI account, I'm impressed.
Yes, the problem is that he has a lot of spending power.
A lot of budget. Yeah,
That's
but
right.
you still can't get the throughput.
I think you can on that key, but within 1 hour you could do some serious damage on that key.
Yeah. You can just tell this to keep going.
Well, first I wanted to. Okay, sure.
Yeah, you can just tell it to do the whole plan if you want. Just put this back on DSP.
1 second. I want to go look at what's the command that I have to run.
Oh, yeah.
And now we can go run this thing.
/.human layer /human layer experimental. Human layer. Amazing, and then just do select star from select AI generated title from sessions.
From here?
Yeah. I think maybe you can only run 1 query this way. Oh yeah, there you go. Yeah, just get rid of the pragma stuff.
Interesting. I didn't know you could only run 1 query from that way.
Maybe there's a flag you need.
Nope, you can run multiple. Just
why is this empty? Oh, this was just creating the column, not doing the backend thing. So it just created the column. Yeah.
Yeah.
Okay.
So I'm gonna let this rip.
Yeah, throw this back on DSP. Option Y. Will you turn on the auto accept flag?
Yes, I will.
Thanks. Okay, you want to go back to the other one?
I do need to do one more thing. I need to stop this from running in the background. Because it's gonna hot reload on every file change.
That's fine. Is that not fine? Can your computer not handle that?
It can, but it's gonna hot reload calling claude over and over and over again. And you don't want that to happen as a developer.
Sorry, it's gonna what?
It's just gonna call Claude code over and over again on every single create session launch, right? Because that's the part of the code
only
that's
when you
added.
go launch a session over there. It's not gonna do it on this one. these two are now sharing like separate database, separate daemon, separate state. So
That's true. Okay.
for the least amount of effort, the get diff will probably be better.
Yeah. It's there you go.
Welcome back to the deep dive. Today we are going to do a full architectural teardown of something pretty fundamental. We're looking at the infrastructure that lets these, trillion parameter systems serve millions of users without just falling over.
We are talking about high-efficiency LLM serving.
And specifically, we're focusing on this unsung engineering hero called continuous batching. And if you're listening to this, chances are you've used a major chatbot in the last, 24 hours?
Oh, for sure. Whether it's a big one like Claude or maybe a local llama model.
Exactly. And you've experienced this really specific performance quirk every single time you use it.
Then the first word pops up.
And from there, the rest of the response just streams out word by word at this blazing fast, super regular pace. That dual experience, that initial delay, then the rapid stream, that's not an accident. That is the direct result of the engineering optimization we're diving into today.
Right.
That first painful pause, that's the model processing your entire input sequence. We call that prefill.
Yeah.
And the speed that follows, that's the result of optimized high-speed decoding.
Exactly. For any engineers and systems architects listening, the core reality you have to get your head around is that LLMs are brutally expensive next token predictors.
Right.
Every single word that gets generated is a massive forward pass through billions of parameters. And if you're trying to run a service at scale, you can't just do that sequentially for every user. Your queues would balloon instantly, latency would be unacceptable.
It just wouldn't work.
It wouldn't work. So our mission today is to really understand the optimization that solves this. We need to maximize throughput, that's the total number of tokens generated per second across the whole system, while keeping that latency low for each user.
And that's where continuous batching comes in.
It does. But to really appreciate it, we need to build a bit of a mental stack first. We have to start at the foundation, with the computational cost of attention.
Okay.
Then we'll introduce two optimizations you can't live without. The KV cache, which solves a redundancy problem, and then chunk prefill, which fixes a memory problem. And only then, when we see how catastrophically wasteful, naive batching is, will the brilliance of continuous batching really shine through.
Okay, let's build that stack. So the core computational unit inside the transformer. A user sends a query, it gets broken down into tokens, and those tokens start moving through the network's layers.
Right.
And a lot of the operations they hit, layer normalization, activation functions, standard matrix multiplications, they're what we'd call token-wise.
Meaning they're independent.
Right, they're efficient. The calculation for token A doesn't care at all what's happening with token B.
But that's not how language works. The whole magic of a transformer is context. The meaning of the word mouse totally changes if it's next to computer versus next to trap. So tokens have to communicate. They need to connect and influence each other's representations. And that happens exclusively in one place, the attention layers.
And that is our bottleneck.
That is precisely where the computational bottleneck lives. Let's quantify this from a systems view. Imagine a simple prompt. Boss, I am sure this project.
Okay, that's 7 tokens. So our sequence length, n, is 7.
Yep. The input tensor, let's call it x, enters the attention block with a shape of, say, 1nd. That's one sequence, n tokens, and d for the hidden dimension.
And for every attention head in every layer, we take that input and project it into 3 different spaces using these learned weight matrices. That's how we get our query, key, and value states, right? The Q, K, and V.
Exactly. Now, the most expensive step, the part that defines our whole complexity profile, is calculating the similarity between every single query and every single key.
The QK transpose matrix multiplication.
That's the one. If your Q tensor has a shape of 1NA and your K transpose is 1AN, the resulting attention score tensor is 1NN. It's an n by n matrix.
So for our 7 token prompt, it's a 7 by 7 matrix. For a 100 token prompt, it's 100 by 100.
And that matrix multiplication dictates the cost. It has a complexity of big O of n squared times d operations. This is the definition of a quadratic scaling problem.
Which means if you double your prompt length, you don't double the work.
You quadruple it.
And this is where the architectural implication just hits you like a truck. If you, the user, submit a prompt of 1,000 tokens, that's one cost. But if you submit a prompt that's 10,000 tokens long, say, you dump in a huge code file,
The computation required for that prefill isn't 10 times greater.
It's 100 times greater. That is the operational horror of O of n squared. And that's why this initial prefill stage is always the slow part.
And it's why we have to be so aggressive about avoiding having to repeat it. Now, we can't get rid of that quadratic cost on the initial input because every token needs to look back at every other token to build context. But what we can do is control which tokens interact.
And that's the attention mask.
That's the attention mask. A simple but incredibly powerful Boolean structure that we apply directly to those QK transpose scores.
So for generation, which is what we're talking about, we use the causal mask. And the intuition here is pretty straightforward. It's rooted in logic. A consequence can't come before its cause.
Right.
When the model is generating the 10th word, it can look back at words 1 through 9, but it has to be completely blind to word 11 because word 11 doesn't exist yet.
Think about that n by n score matrix again. The rows are the token we're currently focused on, the query. The columns are the tokens that are influencing it, the keys.
Okay.
The causal mask just enforces a lower triangular structure on that matrix. Everything above the main diagonal is blocked. It's set to false. It's masked out.
So for our little 7-token example, when we're calculating the attention for token 4, sure.
You're allowed to look at tokens 1, 2, 3, and 4. The mask is true for those columns.
But for tokens 5, 6, and 7, this project, the mask is false.
Right. Sure, it gets no peek into the future. That's how we enforce autoregression.
Okay, so let's formalize this for everyone listening. This whole process we just described, taking the full input sequence, calculating all those quadratic attention scores, and then generating the prediction for just the very next token.
As we said at the top, that's officially called prefill.
It's compute heavy, it's quad scaled, and its only job is to get the model set up for the fast part.
Exactly.
So now we move from prefill to the fast part, the decoding stage. Let's say our model correctly predicted the next token is will. Now we have to predict the token that comes after will. Now, if we were being naive, we'd take our new longer sequence .ject will and just run the whole forward pass again. Recalculate Q, K, and V for all 8 tokens.
But if we do that, we're right back in O of n squared hell for every single token we generate.
The cost would just grow and grow and grow. Streaming a long response would be impossible.
The problem, as you pointed out, is just massive redundancy. Why would we recalculate the key and value states for the first 7 tokens?
They haven't changed.
The input tokens are the same. The weight matrices, WK-UEV, are the same. And because of the causal mask, that new token here, the KV cache, instead of recomputing the KD states for the previous n tokens, we just store them. We put them in a dedicated high-speed memory area. That's the KV cache.
So when the new token, token n+1 will, comes along, we only compute its query, key, and value.
That's it.
And for the attention step, we just concatenate its new key, kn+1, onto the cached keys, and its new value onto the cached values. Then we run the attention calculation for just that one new query against the whole growing cache.
And this simple memory trick is completely transformative. By using the KV cache, the cost of generating that next token just plummets. We avoid that huge n-squared multiplication.
And instead the computation becomes?
It becomes linear, big O of n, because the new query only has to look across the n keys that are already in the cache. This is the definition of decoding efficiency. We've successfully swapped a huge compute burden for a memory burden.
And let's talk about that trade-off, because this is where the engineers listening are going to start paying close attention. We save compute, which is fantastic for throughput, but we pay for it with VRAM. Dedicated, high-speed, expensive VRAM.
And that memory footprint is what directly limits how many parallel conversations you can even support.
Let's do the math on that. The cache size is driven by the model architecture. We need to store both K and V states, so that's a factor of 2. We need it for every layer, L, and it's sized by the number of heads, H, and the dimension of each head, A.
Right. Let's use a common example, Llama 27B. It has L32 layers, H32 attention heads, and a head dimension A128.
Okay.
So if we look at it per layer, for a single token, you need to store 2 times 32 heads times 128 dimensions.
Which is 8,192 values.
8,192 values per token per layer. And since modern inference usually uses float 16 precision.
2 bytes per value.
Exactly. That comes out to roughly 16 KB of memory per token per layer.
Wow. And that's just for one layer. If you scale that up across all 32 layers of the model, you're talking about 0.5 megabyte per token.
The scale is what matters. Whether you think of it as 16 KB per layer or 512 KB get total, the memory footprint is substantial. And think about what that means in practice.
If you want to support a max sequence length of, say, 4,096 tokens?
For just one user, that's 4,096 tokens times half a megabyte per token. That's around 2 gigabytes of VRAM.
2 gigs, just for the cache.
Right, that's before you even think about the model weights themselves or any of the other activations.
So for one long conversation, you've eaten up 2 gigabytes of VRAM. That immediately explains why memory, not raw compute, is the primary constraint in LLM serving.
Absolutely.
If you have a high-end GPU with 80 gigs of VRAM and maybe 50 of that is taken up by the model weights, you only have 30 gigs left for the cache.
And that dramatically limits your maximum batch size, the total number of tokens you can physically store and process at once.
So we've solved the redundancy problem in decoding, but in the process, we've created this massive memory requirement. And now we have to go back and face the reality of prefill again.
Right. The prefill stage is slow, that O of n squared compute, and it's also very memory intensive.
What happens when the initial prompts get really, really big?
This is a real-world problem. If you're an engineer using a coding assistant and you paste in 30,000 tokens of code base for context.
Or you're running a RAG system that pulls in a dozen long documents and staples them together into a 50,000 token prompt. Your sequence length, N, is now massive.
The problem is, to do that prefill in a single forward pass, the GPU has to hold all the intermediate activations for all N tokens in memory at the same time.
And even on a big 80 gigabyte GPU, those temporary activations can easily exceed the physical VRAM limits.
And the whole thing just crashes, or the kernel refuses to launch. It just can't load everything it needs for that giant quadratic calculation all at once.
Which brings us to chunked prefill. This feels like a really necessary patch to manage these memory limits.
It is. It's what ensures the model can handle a prompt of any length, regardless of the physical VRAM on the card.
So how does it work?
The mechanism is actually quite elegant because it leans on the KV cache we just established. Let's say your GPU has a memory budget, we'll call it M, for how many tokens it can handle in one pass. Let's say M is 4,000 tokens.
Okay.
But an incoming prompt, N, is 10,000 tokens long, so we just split it. We split the prompt into 3 chunks. 4,000, 4,000, and 2,000, and we process it in 3 separate forward passes.
So for the first chunk, tokens 1 to 4,000, we do the full computation.
And, crucially, we store the resulting K and V states in the cache.
Then for the second chunk, tokens 4,001 to 8,000, we do its forward pass, we calculate its new K and V states.
But just before we calculate attention, we prepend the cached K and V states from that first chunk to the new ones from the second chunk.
And you have to adapt the attention mask, too. The mask for the second chunk has to let tokens 4,001 through 8,000 look back at tokens 1 through 4,000.
Exactly. The cached KV states are treated exactly as if they were part of the input. That's how you maintain context across the chunks.
It's a clever way of stitching the context together incrementally.
And that decision on the chunk size M is actually a really complex calculation for the system's architect. It's not just about the activation size. If you make them too small, your GPU spends all its time on what's called kernel launch overhead.
Just setting up the computation rather than actually doing it.
Yeah, you're constantly tuning NMM to find that sweet spot between fitting in memory and not wasting time on setup.
So the key insight here is that chunked prefill lets us process these huge variable length prompts without ever hitting that physical memory ceiling.
Exactly. So now we have our tools for single user efficiency. Prefill for the input, fast decoding thanks to the KV cache, and chunked prefill for massive inputs.
But that's all for one user. We still haven't solved the enterprise problem.
How do we serve hundreds or thousands of users at the same time?
This is where we have to talk about batching. So we know that to get high throughput for a high volume of users, we need to run multiple conversations in parallel on the GPU. The first, most obvious idea is just naive batch generation.
You just add a batch dimension. Instead of one sequence, you process B sequences at the same time.
And on the surface, that looks great. GPUs love processing things in batches.
But it has a fatal flaw.
Oh.
The rectangular constraint. GPU kernels demand that your input tensors are uniform. They have to be perfect rectangles.
But user prompts are all different lengths. Some are 10 words, some are 1,000.
So you can't just stack them. You have to force them to be uniform using left padding. You fill the beginning of the shorter sequences with useless pad tokens until every sequence in the batch is as long as the longest one.
And you're immediately wasting compute on tokens that contain 0 information.
And that waste gets so much worse during the decoding phase. Imagine a batch of, say, 64 conversations. One user might be done after 20 tokens. They hit their end of sequence token.
But another user is only halfway through a 500 token response.
With naive batching, the system has to keep running forward passes on that finished sequence just to keep the tensor rectangular until the longest request in the batch is finally done.
So you're generating, what, 480 tokens of pure garbage for that first user? Just wasted cycles?
It's a massive drain. You can try to fix it with some basic dynamic scheduling, pulling out finished sequences and putting new ones in.
But wait, I have to ask a question here. Why even mix them? If prefill is slow and compute heavy and decoding is fast but memory heavy, why not just have two separate GPU queues?
A prefill queue and a decoding queue.
Yeah. Keep the workloads separate, avoid all this complexity.
That's a great architectural question, and it's definitely something early systems tried. The problem is simple. Hardware underutilization. When you run a big prefill batch, sure, you might max out the GPU's compute units for a moment, but then they sit idle.
And the decoding queue.
That's often limited by memory bandwidth, fetching things from the KV cache. So the compute units there are often underutilized too. By separating them, you guarantee that some part of your very expensive GPU is always sitting idle.
You want to keep everything busy at once. The compute units, the memory controllers, all of it.
You need a mixed workload for high utilization.
Yeah.
And that brings us back to the catastrophic problem of trying to mix them with naive batching.
The quadratic penalty of dynamic insertion.
Absolutely. When you try to insert a new prefill request with length n into a batch of existing decoding sequences.
You're forced to stretch the whole batch out to length n.
Right. And since all the other sequences in the batch only need to generate one new token, you have to pad them with n-1 useless positions.
We can actually quantify this penalty. If you have a batch size B and you insert one prefill of length n, the number of wasted padding tokens is n1 times b1.
Right.
So let's run a really dramatic example. Let's say a pretty standard batch size of B32, and a user submits a moderately long prompt, maybe n-2048 tokens.
Okay.
That one prefill step requires 2048.1 times 32.1. That's 2047 times 31. It's roughly 63,457 wasted padding tokens.
So 63,000 tokens of wasted computation.
For one step.
For one step, just to satisfy that rectangular shape. And it gets even worse because powerful tools that engineers love, like CDA graphs or torch.compile, they require static, fixed tensor shapes to work.
So to use those, you're forced to pad everything to the absolute maximum context length your model supports, say 4,096 tokens.
All the time. A 50-token query gets padded with 4,046 useless tokens. Every single time. Naive batching is just fundamentally broken for this kind of workload. It's not scalable. It wastes money, power, and time.
So we have finally arrived at the architectural failure point. It's the batch dimension itself. It forces these rectangular tensors, which cause all this padding and waste, especially when you try to mix prefill and decode. The solution then is pretty radical. You just abandon the batch dimension.
You abandon it entirely. Stop stacking sequences vertically. Instead, you line them up, end to end, into one super long concatenated stream of tokens. This is the move to ragged batching.
Ragged batching. I like that name. It's the foundation of continuous batching.
It is. It means you're handling sequences of uneven or ragged lengths by just chaining them together. So the input to the GPU is now just one giant tensor of tokens.
Yeah.
It's the sum of the lengths of all the active sequences in the back.
And the immediate benefit is?
Zero padding waste.
Yeah.
You are only doing computation on real, meaningful tokens that belong to an actual user request. That's the key to maximizing your throughput.
Okay, but this creates a big technical challenge. If all the tokens are just physically next to each other in memory, what stops token 100 from prompt 0 from paying attention to token 1 of prompt 1?
Right, you can't have context bleeding between requests.
So how do you stop it?
We go back to our fundamental control mechanism.
Yeah.
The attention mask. We build what's called a concatenated attention mask.
Right.
The attention mechanism itself doesn't care about the physical layout in memory. It only cares about the true-false values in the mask. So we custom design the mask.
How?
For all the tokens in prompt 0, the mask is just a standard causal lower triangular block. Same for prompt 1. But the key is that for every query token in prompt 0, the mask value is false for every key token that belongs to prompt 1, and vice versa.
So if you pictured the whole attention mask for the giant concatenated stream It would look like a series of smaller diagonal blocks of true values, with everything else being false.
Exactly. Like high-security fences between the prompts.
That sounds computationally complex to build on the fly.
It is. This is where you need some serious GPU kernel expertise. Standard libraries are built for dense, rectangular matrices. The engineers behind systems like VLLM had to write highly specialized custom CUDA kernels.
What did they do?
They use extra data, like index buffers, that tell the attention mechanism exactly where each sequence starts and ends, so it can apply the mask correctly and efficiently, without actually having to build that huge, sparse matrix every time. That's the trick that makes ragged batching practical.
And this is where the whole thing finally earns the name continuous batching. We combine this ragged batching with intelligent, dynamic scheduling to keep the GPU completely utilized.
Right. It's all about that physical memory budget, Nemeth. The scheduler's one and only goal is to keep the number of tokens being processed as close to 100% of M as possible at all times.
And it does this by following a strict priority list for every single forward pass.
That's right. Priority 1. Load all the decoding prompts.
Why them first?
Because they're latency sensitive. These are active user conversations. And they're cheap. Each one only adds one new token to the stream because the rest of its context is pulled from the cache. So you load every single active decoding request first.
Okay, so that's priority 1. What's priority 2?
Priority 2 is fill every last bit of remaining space with pre-fill prompts. This is the genius move.
Right.
Let's say your decoding prompts only used up 200 token slots out of your total budget of 4,000. You have 3,800 slots left. A new user submits a 3,000 token prompt.
You just slot the whole thing in.
You slot the entire thing in, and the batch runs. It processes the 3,000 tokens for that prefill and the 200 tokens for all the decodes, all in the same pass.
But what if the new request is 5,000 tokens long and you only have 3,800 slots?
You don't throw it away. You lean on chunk prefill. You just carve off the first 3,800 tokens of that new prompt. You insert that chunk to perfectly fill the budget, you process it, and you store its KV states.
And the remaining 1,200 tokens just wait for the next cycle.
Exactly.
This is what makes it continuous. As soon as a sequence finishes, it hits that end of sequence token, it's evicted from the batch, its memory is freed up, and that empty space is immediately backfilled, maybe by another chunk from a big prefill request that's been waiting.
There are 0 wasted cycles, 0 idle memory. The batch is never static. It's this constantly evolving living thing that's always optimizing the token level utilization of the GPU.
And that is why continuous batching is the core infrastructure behind all modern LLM serving. It just systematically knocks down all the bottlenecks we identified.
The quadratic cost of prefill, the memory cost of the cache, the VRAM limits for big inputs, and that catastrophic waste from padding. It takes these completely different workloads, long prefill, short decode, and fuses them into one incredibly efficient pipeline.
So to synthesize this for everyone, continuous batching isn't just one thing. It's a whole architectural framework.
It's built on 3 integrated pillars that really enable LLM deployment at enterprise scale.
Okay, let's list them. Pillar 1.
KV caching. That's the foundation. It's what turns generation from a compute-heavy O of n squared problem into a linear O of n problem by trading compute for memory.
Pillar 2.
Chunked prefill. That's what lets the system ingest these massive variable-length prompts by breaking them down and processing them incrementally without ever hitting the physical VRAM ceiling.
And pillar 3, the core innovation.
Ragged batching with dynamic scheduling. That's what eliminates all the waste from padding and ensures the GPU is always fully saturated by constantly mixing and replacing requests in the batch.
So for you, the engineer or the systems architect who's focused on cost and deployment, understanding this is just, it's non-negotiable.
It is.
The ability to guarantee near 100% GPU utilization, especially on these incredibly expensive H100s, that's the difference between a profitable service and an infrastructure bottleneck that just bleeds money.
Right. Maximum throughput directly translates to a lower operational cost for every token you serve.
Exactly.
And, continuous batching optimizes how we use the cache space. It ensures the computation is always useful.
Yeah.
But now I want you to look at the memory itself. That massive KV cache, that 16 KB per token per layer, it's still fundamentally managed as these big contiguous blocks of memory.
A block for each request.
Right. And as we're constantly inserting, terminating, and chunking these requests, the memory gets fragmented. If a sequence needs to grow its cache, but the block of memory next to it is already taken, what do?
You have to copy the entire block to a new, bigger location somewhere else in VRAM.
Causing these little latency spikes from all the data copying. That structural memory inefficiency is the next problem that continuous batching on its own doesn't solve.
So what's the next step?
The next question is, how do we make the physical memory management itself as dynamic and flexible as the batch scheduling? How do we make it non-contiguous, like how an operating system manages virtual memory with pages?
So that leads to page detention.
It leads directly to page detention.
Mm-hmm.
So the provocative thought I want to leave you with is this. Think about the immense complexity of trying to map the logical token sequence of a constantly changing request onto fragmented, scattered physical memory pages in VRAM, all while running at line speed.
That's the next great leap in serving efficiency.
And a challenge definitely worth mulling over until our next deep dive.
That is a perfect challenge to leave with. Understanding continuous batching solves your throughput problem. Mastering page detention solves your memory fragmentation problem. Until next time.
everyone. Great to be here. Today we're talking about RL environments and how to scale them. But the title's a little bit of a red herring. We'll talk a bit about the engineering pieces and like running these with thousands of parallel rollouts and sandboxes on hundreds of GPUs. But I'm mostly going to focus on a different notion of scale. But what I mean by scaling here is there's a number of different ways we talk about scaling in the context of AI and research. We know about scaling laws, and we talk about how much data you need, compute, and parameters, and that if you pour in more data and compute and parameters or inference time, all of these things make models smarter or more performant. But there's also a fuzzier side of scaling, which is sometimes referred to as unhobbling or algorithmic tricks or talent. But where does this come from? It's not just pouring in resources, but it's something that is more intangible, harder to put a finger on. But really it comes from a community of people, a company, an organization, universities, the world, the internet, talking about ideas and sharing them and working on different applications, having these applications inspire ideas, using these ideas as test beds for different techniques, and building on top of these to increase the accessibility for other people in the future to not have to reinvent the wheel and to be able to build from what has been done by those before them to do more effective research and accelerate the pace of innovation. And so why do we have this talent bottleneck? There's a big issue that we hear all about with AI labs trying to like find more talent, and salaries are going through the roof, and everyone wants to hire the best and brightest AI researchers. But one other approach, besides trying to just pay the most, is increase the pool. And so how do we increase the pool of AI researchers? How do we make doing AI research more accessible? And I want to talk a bit about who we are at Intellect. If you haven't heard of us, we are a bunch of things. We're a research lab, we are a compute provider, we're a platform company, and we are an open source ecosystem. We do a lot of things, and they all fit together in a way that I'm going to try to explain in this talk. But we see these as all different pieces of how we can build a business around doing exactly this, which is increasing the accessibility of AI research and making doing research more of a toolkit available to people at organizations around the world without needing to be inside of a large lab or without needing to spend crazy amounts on massive clusters or go to a PhD. We think that there's versions of doing AI research that really should be part of the bread and butter workflows of AI engineers around the world as we build applications and try to improve our systems and models and products. And I think a thing people are kind of iffy about in terms of AI is whether open source models are going to work. And in my mind, that's not quite the right analogy to draw. And so when we're comparing like AI to traditional software, there's lots of like great examples of open source software ecosystems that have been thriving in the past, things like Linux and Node and Apache. But in my mind, the analogy in AI is not models as kind of these fixed checkpoints, but it's about research as a practice and research as a set of ideas. And it's one that's more intangible, but there's a lot of parallels in terms of the goals of the best practices of growing a research ecosystem as well as a software ecosystem, where you want to compound abstractions and best practices and have better tooling and iteration efficiency, and have these gains over time allow more advanced, powerful, complex things to be built by decreasing barriers to entry for any given application and allowing this to become more accessible. And so one thing that a term we'll use to describe some of what we're building at Prime Intellect is we like this phrase called the Open Superintelligence Stack. One, because it's a fun acronym, but also I think the idea of the stack of all the pieces of the puzzle to build the engine to go do research. There's a lot of layers to it. You need compute, you need orchestration, you need libraries for doing training and evaluation, and you need platforms to support things like code execution and evals and inference and fine-tuning. And we're doing all these things. But really the goal of this is to give people the tools to be able to go train models. We want more people in the world, and we think I'll explain why in a bit. There's a lot of reasons why the best products are going to be the ones that are not just kind of taking the thing out of a box of an API and putting a thin wrap around it. There's ways you can kind of improve around APIs, but I think in many cases people are realizing that winning products are going to be the kinds of things that, whether it's a part of the model, or a part of the stack, a part of the product, or the whole thing, the ability to do research and have at least the option of deciding where in your product you might want to customize a model or improve a model gives you a lot more flexibility to really make the best user experience. And so we have heard the phrase in the past that the model is the product, and I think we're starting to see now this change a little bit to a lot of winning applications have the product kind of be the model. And I think the two notable examples of this that I'm big fans of and heavy users of are Cursor's new Composer model as well as OpenAI's Codex. And I think these are both good examples of models that really are where the product kind of is the model very directly, where the model was trained to be the model for that product. And the experience of using the model is the experience of using the product. And the way that this is done is by taking a harness that represents the product and training the model in the harness in essentially an environment, an RL environment. And environments really are just a harness with a collection of tasks and rewards, but they also have many other parallels throughout the ecosystem. Environments are not just for RL. Environments are also essentially the same thing as evals. Environments can also be engines for synthetic data, which then you can use for SFT or distillation. You could do RL them directly, but also the agents we're actually deploying and monitoring out in the world, these are environments. The product of these things, the tasks, the harness, and the rewards, whether this is a data set offline or the stream of user tasks coming into a product, is an environment. And so this as an abstraction, I think, is a very useful way of framing what it might look like to start having research become more of a practice that is adopted more broadly beyond just large AI labs. And I also think that there's a sense in which they're a really accessible entry point. And so I like the analogy of environments as kind of like the web apps of AI research. And what I mean by this is that they're very simple, they're self-contained, they start simple, but they can also get quite complex. They can get very elaborate, representing the full complexity of a large product. They're also pedagogical in nature, in that you can start simple, and as you build complexity, you start bumping into these walls where you have to start learning new concepts, understanding more about scaling the system side, understanding more about the hyperparameters and the algorithms. And they kind of open this door where you can, by playing around with them, start entering into a world of research without needing to kind of build a whole training infrastructure system from scratch. And they also require experimentation. And so I think the key differentiation between just an agent harness and an agent environment is that the environment forces you to also have your tasks and your rewards predefined to be able to do this experimentation. It's a proper eval. And what this means is that you can't just vibe check it. You can't just like build it and test it out a bit and say, hey, it's good, we're going to ship it. It forces you to say, okay, let's think about this a little more scientifically. Let's do some experiments. Let's try out different models, try different hyperparameters. And it also gets you to the point where you can start doing more advanced research in terms of RL training or distillation or fine-tuning. And so to really facilitate this, we wanted to make the environment as an entry point much more accessible. A few months back, we launched what we called the Environments Hub, which is a open source community platform for creating, discovering, and sharing RL environments and evals. And so far, we've had a lot of fun kind of seeing everyone build here. We've had hundreds of builders and environments come create either their own ideas or re-implement papers. There's a bunch of examples here I can show you, but really it's just a bunch of people who have wanted to do research and found this as an entry point to start digging a little deeper, whether this was investigating some benchmark and figuring out how to re-implement it or modify it to be appropriate for an RL context in terms of like new data or new examples, or whether this is some game that they'd been thinking about or some other task. But having this as an abstraction for encapsulating the thing you want the model to do is a way of allowing yourself to start experimenting with ways of improving it without needing to have the answers. So I think people talk a lot about how fine-tuning never really took off in the SFT regime. And I think a big part of this is that getting data was really hard of the actual like solutions. I think having examples of what you want the model to do is a very difficult thing to ask someone to go create. But if you can just think about the settings it might be in without having the answers up front, if you can measure the answers, now you kind of can start creating data on the fly. And this engine is really what the environment is about unlocking. And so actually 9 months ago, I was right here in this room, I had just released a library called Verifiers, which I'm still working on today. It's come a long way, but it's a toolkit for building these things. And it's been a lot of fun over this past year, just playing with it and extending it to support more features and kinds of environments. But the idea with Verifiers is to give people a toolkit that is essentially a bunch of components that you can mix and match and compose to do things like from simple evals or QA or games to things like tool use or using sandboxes or agent frameworks or like CLI coding agents or math problems. There's all sorts of things you might want models to do or agents to do. And it's a toolkit for building environments that is then ready to be automatically trained with reinforcement learning. And the way we thought about this design, it's been a lot of fun and also a big challenge to think like, okay, how do you make a toolkit for this stuff that actually covers all the bases? And I think there's a lot of different approaches I've seen people go about, and I think they all make sense depending on what sorts of things you're wanting to work on. But we took a very kind of a general approach where we tried to say, we are not going to know all the answers right away. There are going to be lots of patterns. There's going to be lots of special cases. There's going to be hierarchies of complexity. There's going to be patterns. And we really want to prioritize extensibility. So we think about these things hierarchically, where let's say you want to do a coding agent environment for Client Bench, which is an instance of the Harbor framework, which is an example of a CLI agent, which is a multi-turn environment, which is an environment. Similar for Textarena and Wordle, or for search with MCP, or for giving a model a Python REPL in a sandbox. And so thinking of these things hierarchically allows us to kind of really determine like what are the foundational pieces, what is generic across all environments, and then how do you build up the stack towards applications. And so for one like example of this that I'll kind of walk through the whole process end to end, we call this one wiki search, but it's basically a simple search setting where we give an agent the ability to call some tools to search over Wikipedia pages and find some answers. And so here is the Environments Hub page. So the Environments Hub is a kind of full stack code management package registry. So every environment is a Python project where you can have dependencies and versions and uploading your evals and whatnot. But the environments are very simple. They start simple. They can get really complicated, but this one's pretty simple, where we just kind of define our tools as async Python functions. We have our data set, and we have what we call a rubric. And so a rubric is the abstraction for managing the different pieces of your rewards, where you can kind of compose different things. You can also have metrics that are just a zero reward, but are for observability of what's going on. And then the other piece of doing training will be a config. And so the config here is for our prime RL trainer, which is our kind of large-scale training stack, which has been our culmination of all the best practices from the research literature for large-scale asynchronous RL training. But the config files are intended to expose kind of the pieces that people need to think about in ways that are starting to get you more into the algorithm, but are also still designed to be pretty high level, pretty self-contained, and with defaults that we think are going to be sensible for a lot of people. And so running this is just kind of running a command line with, you specify the environment, and if it's in the environment hub, it'll automatically install it and start your training run, and then you can, if you're lucky, see your reward curve just shoot right up. And sometimes it doesn't go this nicely, but the process of doing this is iterating on your environment, on your rewards, and your data, and your tasks to understand what makes this task holistically actually tangible in practice. How do you tune the parameters? How do you look at your data? How do you define your rewards? And if you do this right, you can get really good improvements, especially from really small models, but also from much larger models. And so in this example for the wiki search one, we started with a Qwen 3 4B model, which was about 55%, and after training it was at 89%, on par with much larger models like GPT-4.1, as well as reasoning models like GPT-5 Mini. And so I think this practice of taking small models and being able to make them much better is a big win for a lot of applications, where either you want a really fast model, you want a really cheap model, you want a really, really powerful model because the best models out there just aren't quite good enough. These are all the different things you can do with model customization. And this practice of creating environments isn't only for customization, but it gives you this option. And so if you need to do evals anyways, it's useful to think of them as environments, because the environment opens a lot of doors for whether this is prompt tuning, or whether it's model selection, or whether it's just getting a better sense of how your system could work at scale with many, many users in parallel. It's a design process that really forces you to kind of pin down what is the thing I care about, what is my agent, what is my product, what is my harness, what am I optimizing for? And so to kind of fully stress test this, we've been training a large model, which will be out into the world quite soon, called Intelec 3, with our full prime RL stack. And this has been us really kind of validating the efficiency and performance at a very large scale. So this is a 100B plus model trained on 500 GPUs, where we've kind of done the end-to-end post-train of SFT and RL, which just getting a better sense of how your system could work at scale with many, many users in parallel. It's a design process that really forces you to kind of pin down what is the thing I care about, what is my agent, what is my product, what is my harness, what am I optimizing for? And so to kind of fully stress test this, we've been training a large model, which will be out into the world quite soon, called Intellect 3, with our full prime RL stack. And this has been us really kind of validating the efficiency and performance at a very large scale. So this is a 100B plus model trained on 500 GPUs, where we've kind of done the end-to-end post-train of SFT and RL, which the prime RL stack also has SFT if people want to do that. But it's also been about just understanding all the best practices. We love reading papers, and we try to kind of try out all the tricks and see which ones work and see which ones don't, and then distill this into a library with prime RL that can then be kind of consumed by the end user without needing to do all this implementation themselves. And so for us, it being open is very important. So prime RL is on GitHub. You can go find it. Verifiers is on GitHub if you want to check it out. And for us, this is really about opening the door for more people to start learning about these things and for incorporating it into their workflows for optimizing their models and their products. And the only way to do this, what we see as the best way to do this, is through growing community. And so for us, it's been really important to really think about getting good feedback loops from the people who are building with this and understanding what they want, understanding what's going well, understanding what's painful, and addressing those problems. And so we've done a number of community programs in terms of sponsoring different kind of small tasks to a research residency program with grad students around the world, and collecting like a smaller subset of the Environments Hub ones where we'll actually review them manually. And so this repo here, the Prime Environments repo, is the ones where we are doing these directly, where we're kind of offering to look over someone's kind of example implementation. And so we've had hundreds of these come in, and there will be hundreds more. And it's been a great learning process because it's forced us to fix a lot of things. We kind of understand the rough edges, we understand what we need to add, and we're kind of then distilling all these learnings into what will be our kind of upcoming platform product, which we're calling Lab. And the idea of Lab is to give people an interface, a platform where they can browse environments, they can run their evals, they can do their inference, they can do their fine-tuning, and they can have research be more accessible in a way that it hasn't been historically. Because I think a lot of people find infrastructure very painful. They find dealing with torch versions painful, flash attention, VLLM, and getting all these things to work. We are happy to do that, but we understand that a lot of people may not want to. And so the idea with this is that if you want to go read the code, you can go read the code, but you don't have to run it. You can run it for you. And so this has been our version, which will be kind of out into the world in the near future, of trying to allow people to really focus on the environment, where the entry point to Lab will be the environment. If you want to do synthetic data in SFT, let's build an environment. If you want to do your evals, you build that as an environment. If you want to do RL, you build an environment. And I think building an environment is the kind of thing that I imagine a lot more people are going to want to be doing as we start really seeing where models are headed. In some cases, this will be we're going to use fine-tuning services from the labs because they're going to offer this because people want it. In some cases, this will be we really care about the smallest model we can run on-prem at the lowest latency, and we're really just going to optimize for our one thing. Or it could just be research for the sake of research and advancing our kind of collective understanding of how this stuff all works. And I think that's really our goal, is to have a world where there's going to be a lot of AI and where we can all kind of talk about it and understand it and look at it and poke at it and tweak it and have a better sense of what we're actually building. Because I think there's a lot of times when it feels like we're just kind of the model is a black box, and digging into the research and going under the hood and changing things and breaking things tells you a lot about how these models work. It tells you a lot about understanding where they came from, where they could be going, where they might be headed, and preparing for that future. Thanks.
Our next speakers are here to present a deep dive into OpenAI's approach to reinforcement fine-tuning for code models. Please join me in welcoming to the stage members of technical staff at OpenAI, Will Heng and Kathy Zhou.
Hey everyone, I'm Will.
And I'm Kathy, and we're on the fine-tuning team at OpenAI.
And we're super excited to talk to you today about Agent RFT, the most powerful way to enhance the performance of your agents. So you're probably joining us today because you're building an agent for your business and you'd like to improve its performance. So let's first start by talking about what an agent actually is. What makes an agent different from a regular model is its ability to interact with the outside world to complete a task to get things done on its own without having to go through you all the time. So this agent needs to have access to tools. For example, if you're building a coding agent, it's got to have access to a terminal, a code interpreter, or maybe even an entire code base. But these agents aren't just blindly calling tools. They're reasoning at the same time. The way that we think about these agents is that their interactions with the outside world, such as tool calls, are interleaved with their reasoning traces in the same context window. So an example of an agent that we've built in-house using this paradigm is Codex. Codex is our flagship coding agent. It has access to a wide range of tools to complete coding tasks end-to-end, like writing unit tests or submitting large diffs to your code base that are hopefully correct. Some tools are exposed as terminal commands, and other tools are custom functions a model can call to invoke, say, a planning workflow. So now, how do we make our agents better? We're all probably pretty familiar with the frontline techniques to improve the performance of agents. For example, for starters, prompt engineering or prompt optimization. Prompting, you can steer model or agent behavior to align more with your preferences. But let's say you still want to squeeze more juice out of your task. Well, you can then turn to task optimization. You can simplify the task. You can add better guardrails around the task. You can add and subtract tools, or you can change tool behavior to work better for the agent. But let's say you still want to squeeze even more juice out of that task. You've tried all these approaches and you still want better performance. So that's where you would turn to fine-tuning. Fine-tuning is a way to train the agent end-to-end on your task to achieve even better performance by changing the weights of the model. And agent reinforcement fine-tuning, or agent RFT, is the way to do this, or it's the way that we would like you all to do this. Agent RFT changes the weights of the model according to a learning signal that you specify to teach the model what good behavior and what bad behavior looks like. And during training, the agent will explore many different ways of calling your tools to solve your task. So we've introduced several major new additions to the RFT product. First off, the model can now call your tools via your endpoints that are hosted in the public internet. And after each rollout, we'll also invoke your custom reward signal that's hosted via an endpoint. So these two additions actually mark the first time that we at OpenAI have allowed models to interact with the outside world during the training process. So I think this is pretty cool. To summarize, the benefits of Agent RFT, it helps you improve the performance of your reasoning models, but more specifically, the reasoning models that have to call tools and interact with the outside world to get things done in a multi-step fashion. Agent RFT is also quite sample efficient. We've seen people get success from literally only using like 10 examples, which is pretty amazing. We'll go over specific examples of this when we deep dive into some of our customer spotlights. And it results in a model that has lower latency and just works better for your tasks. So now let's dive a little bit deeper into how all this works. One of the challenges with making agents work with your specific business context is that your environment, your world, might just be different from how we train our models in-house. So this phenomenon in ML is called domain shift. And it can result in an agent that doesn't quite call your tools that well. It might call a tool too many times, or it might just straight up shove wrong inputs into your tools. Agent RFT can readapt the model to your domain through this weight-changing training process that results in an agent that actually understands your environment. And this has some really nice properties. Obviously, better ML performance. It trains the model to use tools better, and it trains the model to reason over the outputs of those tools better. All this is learned organically by the model, while it explores the search space, all the possible ways of interacting with your environment, and hill climbing on your reward. Another really nice property that results from this is the ability to achieve much lower latencies by making sure that the model stays within a given tool called budget and doesn't go over that limit. So we can actually impose this penalty that penalizes the model for going over that budget. What actually happens is the model learns to stay within that budget while preserving or exceeding the original ML performance. So to dive a little bit deeper into what happens at a systems level, for each agent rollout, we'll produce this unique identifier that specifies that particular rollout. And we will associate all the tool calls that we make into your system with that UUID. And so we do this for every tool call so that you can keep track of a trajectory as it evolves, so that when we emit that final answer at the very end, you can then associate that final answer with all the context that you've maintained so far, and you can just pass this whole thing as a holistic grading context into your grader. Now, we don't recommend everyone or anyone just use agent RFT right off the bat. There's a process that we'd like you all to follow. You first want to make sure that your training dataset and your eval dataset closely match your production traffic. You do not want any drift whatsoever. Then you want to ground yourself in a baseline. You want to run your base model against these datasets so that you kind of understand what to expect performance-wise, so that you can then hill climb from there. And then you want to optimize performance using some of the techniques that we talked about prior, like prompt or task optimization. And only then, when you still feel like you squeezed all the juice out of the task, but you still want more juice, you would turn to agent RFT to push the frontier for your task. So now I'm going to turn it over to Kathy to talk about how some of our partners have really pushed that frontier.
Yeah, so now that we learned how agent RFT works and when you should use it, I'll show you some coding-related examples of how our customers were able to use agent RFT to make their agents better, and also highlight some key takeaways that you can apply when optimizing your own agents. So a few months ago, we partnered with Cognition, who use agent RFT on their code edit planning phase. This is the part where Devin inspects a repo and runs shell tools like rep and file reads to decide which exact files to edit. To train this behavior, they built a dataset of user queries paired with actual files that users has modified. And they use the F1 score of the selected files as the reward. This F1 score is really great because it balances between the precision and the recall. So this ensures that the agent doesn't return too many inaccurate files or misses the critical ones. They also built extremely robust infrastructure to support this training. So in this case, for each individual trajectory, they spun up a VM to manage the code base, to execute the tool calls, and grade the final answer. These VMs make sure that the environment is isolated so that the shell tools will not affect each other in different rollouts. We saw two important takeaways from Cognition's use case. First, data quality and the volume really matters. So at first, they fine-tuned on a data set of around 100 examples and were able to get a 5-point improvement. But when they scaled to 1,000 examples, the improvement jumped to 10 points. So the number of high-quality examples you provide can very directly translate to a better agent behavior. Second, we also learned that RFT is really good for learning to call tools in parallel. So in this case, the model would initially take 8 to 10 steps, alternating between generating tokens in its reasoning to actually calling the tools. After RFT, the agent launches many tool calls in parallel at the very first step. So this was able to reduce that number down to 4. And in this use case, the speedup was especially important because they wanted Devin to start producing edits quickly. And now I want to highlight a different use case. CUDA is building a code review agent, and a key piece of that is a deep research agent that answers developer questions on large code bases. To improve this deep research agent, they trained GPT-5 to answer coding questions by calling tools like search and retrieve over the repository. They assembled around 1,000 authentic question-answer pairs from 8 different repositories and rewarded the model using the recall of how many relevant facts the agent were able to retrieve. With RFT, the agent improved by 6%, and it was using fewer tool calls and output tokens. And what we found most interesting is this graph, where it shows how RFT shifted the distribution of the number of tool calls. So with base GPT-5, the agent would occasionally fall into these bad runs, where there were more than 15 tool calls in a single sample. This is very slow and also can lead to some inconsistent behaviors. So after RFT, these tool calls that are very long tail disappeared, and the distribution centered to just around 2 to 4 tool calls. In this setup, RFT didn't just improve accuracy, it also stabilized the agent's behavior in eliminating these P95 long-tail cases, and this is very important for production use cases where your latency will matter. Next, I want to share how Cosign built coding agents for large and complex enterprise code bases with agent RFT. To make this work, they trained the agent on a very comprehensive set of 30 tools, such as file read, keyword search, session terminal, browser sessions, etc. And they also built a very strict grader. So they observed that the model originally, when they were providing the model with partial credits and points for just trying out things, it didn't get really good results because the model would start to optimize things on coding style and tone. So at first, they want to really make sure the agent ships working code. And so based on that, they give the model the reward only when the final code passes the test. And because the grader is very strict, it can sometimes give sparse rewards. In that case, GPT-5 is actually very great because it can give us some samples that work. So Cosign also boosted the batch size, and they increased the amount of compute so that there is even more samples that can give us positive rewards. So it's not like every single sample in the batch will give a 0 reward. Once the code is correct, they also have a custom LLM that would judge by the score and tone. So it will penalize verbosity, emojis, or anything that feels unprofessional. finally, the grader will reward the agents that validate their own work. So this means running tests, inspecting terminal outputs, and also checking linting before calling out a success. And after training with this very thoughtful set of tools and graders, Cosine was able to reach the state of the art on a lot of different benchmarks over here. And they also got a much faster agent. So like in earlier examples, RFT shifted the distribution of tool calls, and the agent stopped taking these extremely long trajectories. In this case, there was sometimes more than 100 messages in a single trajectory. And it converged to a much tighter and more efficient sequence of steps. Lastly, Mako is a very interesting use case. They're building agents that write highly performant GPU kernels, which is traditionally very hard for LLMs, because in normal use cases, there's a lot more examples, but in this case, there's not a lot of example for kernels, especially if you're using new hardware platforms like NVIDIA B200s. With Agent RFT, Mako trained GPT-5 to write fast kernels using only about 100 PyTorch prompts. And this was a major unlock. So we don't actually need that many samples and kernel data set in order to train a good model that produces kernels, and we just have to specify a good reward function. In this case, specifying a good reward function is also very hard. Early in training, they observed that the model was reward hacking. So what they did was that they inspected the rollouts, and they found 7 different cases where the model was hacking. And this includes things like just returning the reference code, or returning no-op kernels, or identity kernels. And they built a judge LLM to catch all of these 7 cases and reward them with a 0. They also added a static analysis tool with an abstract syntax tree to verify that the generated kernels actually exist and they're actually being launched. So after they made sure that there was no reward hacking, they also scored on correctness and real speedup compared to the PyTorch baseline. Once all of these protections were in place, the agent got significantly better than GPT-5. And Mako also used a really smart technique here to improve the performance even more. They ran 3 different samples, and they took the best one out of the 3. This allowed them to beat the state of the art by 72%. And yeah, I'll hand it back to Will.
Thanks a lot, Kathy. So now we want all of you in this room and beyond, to be as successful as the partners that Kathy just mentioned with Agent RFT. So here are 4 key principles to ensure your success. First of all, you want to make sure that your task is well-defined, well-constrained. There should be a clear, unambiguous definition of success. You should have removed all subjectivity out of your task. Taste should not be a requirement to grade your task properly. Next, you do not want the model to feel surprised in production. You want to make sure that your train and eval datasets mirror your production traffic. So none of that domain shift that we talked about. You do not want to introduce that domain shift on your own. Next, and this is a really important part, you want to make sure that through exploration, the model actually achieves better performance on a given data point if it samples more, so that it can learn from itself. So what this means is if you take the maximum performance on a given data set, that should improve as you sample more from the model. So because of this, you should be able to see these variances from a given data point, so the model can learn from itself, learn what the difference between a good and a bad rollout is for a given data point. And lastly, you want to make sure that your reward function is not hackable. Hopefully you've plugged up all the corner cases, all the edge cases, but also hopefully you've framed your task so that the reward is more continuous than binary. The continuous reward actually allows the model to kind of inch up closer and closer to optimal performance, sort of like giving a student partial credit, rather than slapping the model in the face or giving it a cookie if it gets stuff wrong or gets stuff right. So now, in order to get started with Agent RFT, please contact your friendly neighborhood account director, and we're really excited to see what you all build with us. Thank you so much.
Our next speaker will talk about the future of front-end engineering in the age of software collaboration with AI agents. Please join me in welcoming to the stage, Kitsy.
That's my old profile photo, all right? This is my new one. I've been 3 days in USA, and I already got the full merch package on Twitter. So if you go and follow me on Twitter, my timeline is going to be weird for next week, but then we're going back to normal European schedule, don't worry. So I visited some of your museums. I love it here. These were some of my favorite things that I've done. I enjoy like exploring your culture, like doing all the cultural enrichment. And yeah, round of torture for myself. Who knows me from Twitter? All right, that's more than I thought. Who is using Sizzy? It's usually like one person in the back. Usually the janitor doesn't even listen to what I'm saying. One of the things that I'm working, I have ADHD, so I'm working on a billion things at once. This is one of the things. It's a browser specifically made for developers, not made to replace your browser for browsing, but it's just like a tool like Photoshop that's like helping you in a lot of ways to do front-end development. Another thing I'm working on, the test slide is almost live. I'm making a life OS which combines like all the things in your life from medication, habits, to-dos, planner, blah, blah, blah. This is like a full stack thing that I'm working on. It's currently on scale. It's called Zero to Ship. And the last thing that I'm reviving is called Glink, which is like changelogs, roadmap, a billion other things. So without overwhelming you more about my bio and stuff, I really hope I'll get invited next year because I love it here for reasons like networking and meeting people and teaching. It's great, but you're laughing, right? But let's just discuss why are you here, right? You're here for learning, and you're here for like networking, and later, after this, you're definitely going to improve all of your skills later. All right, so what can you expect from my conference talks? If you haven't listened to any of my conference talks, usually, this was made by AI, so it's completely wrong, so it's like 50% tweets, 40% pain, and 30% reason to remember the name. So in 2017, I did this talk with the longest name ever. It's called Navigating the Hype-Driven Front-End Development World Without Going Insane. And I've been talking about like how to navigate the front-end world then. Now it's even crazier, but we need to recap like all the things that happened since 2017. I don't see my speaker's notes, which is bad, but we'll try to get by. So in other industries, like in the Vision Pro, you have like cloth collision on top of real life objects and whatever crazy stuff is happening here. In here, we have like some slicing of a mesh texture going around the ball and blah, blah, blah. Whatever these waterfalls and like all of this mesh, like you can take a rock and just smush it into another rock and it magically kind of like blends itself and it forms this structure and it's freaking crazy. Here, we can drag our mouse and just create buildings and streets and taxi cars spawn out of nowhere and like we do generative, whatever the hell this is. And honey, goo thingy coming on a cube and like, you know where this is going, right? I'm building up to where it's going. But because you have respect for your profession and you love your LinkedIn title, whatever it is, you're like the CEO, architect of dreams, blah, blah, blah. You're going to try your best not to laugh, but you're going to laugh at the next slide because this is what happened in front-end development. It's been almost 10 years, and this is where we're at. There's a warning saying that maybe you'll be able to style a select in 2037. This is still alive. It's a freaking miracle. This is still alive. It's thriving, actually. 15 million downloads. I set up like a calendar event to check if it's dead every year. It hasn't been dead yet, so I'm going to keep checking. CLIs, not only that they're not dead, they're actually thriving. You can drop images. First time I dropped an image in my terminal, I'm like, how the hell? Oh, never mind. Like, it's too... I added another calendar event. At this point, I have more events for this than anniversaries and birthdays and stuff, so I hope one day it's going to die as a concept. We're struggling with the same old pains. Soon, in maybe some browsers, you won't need JavaScript to style a popover in a dialog. Can I have like a round of applause for that? Stop clapping because people have brain implants, all right? It doesn't matter if you can style a dialog. We cannot get rid of Internet Explorer. We just updated the logo.
It's still there, it's still painful, and yeah. We cannot agree on a way to increase a counter. This is a demo from Ryan Florence. This is remix version 2, the version 3, the remix of the version 4. Whatever they're doing, it's a counter. How complex is it to increase a counter? It's incredible. And don't shoot the messenger here, but the number one library is still the same. It's annoying, but React is the best, and blah, blah, blah. So let's talk about LLMs. LLMs are amazing at writing React. And this is funny, only to us humans, right? To an LLM, this is like perfectly written code. It's only a human wish to abstract the shit out of this, right? So when we see this, you get this urge, you want to get on stage right now and go, oh, let me just change that. I'll make it more optimal. So here's some scientific brain scans. This is our brain on cocaine. This is our brain on sugar. This is our brain when we realize that we can abstract something. You're like, oh, let's go. It's useless to the user, but we freaking love it. So coding with LLMs makes this kind of better and worse, like especially with Composer 1, for me, it's like way worse, because you can get to the right abstraction quicker, but you can also get to the wrong abstraction quicker. And the best thing here is LLMs don't care about repetitive code, and I've been saying this since 2017, that we care too much about repetitive code and we abstract too early. So I'm going to repeat this a couple of times, and I love that LLMs don't care about repetitive code. So LLMs are also good at writing React, because no one is actually good at writing React. You go to a React conference, every conference that I went to, like, you just listen to the first talk, and you're like, holy shit, it can do that? I was using it all wrong. So everyone is just inventing their own ways of doing React. So when we say, like, yeah, but you cannot do the optimal use effect, blah, blah, and the machines cannot write the proper, can you write a proper use effect? No, you can't. So we should stop blaming the machines. So let's talk about this. I think this is the very wrongest audience for my talk here, because I've been giving this talk at conferences where people are like at least 50-50 hate vibe coding and love vibe coding. So I hope it will work here. So raise your hand if you think that vibe coding rocks. Okay, that's way too many hands. You should see this in another city, just 2 people, and everyone else is grumpy. So raise your hand if you think that vibe coding sucks. Please, couple of hands. Hell yeah. All right. So I'm here to convince the rest of the group, and hopefully people watching the live stream, there's way more skeptical people. You have no, if you just landed on Earth maybe, and you don't know what vibe coding is, okay, 0 people here, so yeah. All right, all of you are right, because we're kind of vibing the definition of what vibe coding is, and since the word was mentioned, we kind of expanded it to mean like everything and anything. So the term vibe coding was coined by Andrej Karpathy. You probably know this. He's the reason that idiots sleep in the back of their cars and film TikToks. So he wrote this long essay on what is vibe coding, but the long story short is like, you don't care that much about the code, you press accept, and you just tell the LLM to do what it needs to do, and blah, blah, blah. Now, this is a slide from my talk in 2017, before LLMs or anything was mentioned, when I said that if you see the pattern of where front-end development is going, one day is going to be like, everyone is working on things that are so similar, that one day you'll be able to be like, hey, just give me new styles for the header, or move this 3 pixels to the right. And people were laughing, they're like, no, it's not going to get there, and literally this is what we're doing with cursor and everything else, right? I'm too lazy to go into Tailwind and just move it by 3 pixels. So I'm a time traveler. Managers have been vibe coding forever, so this is nothing new. So they tell a developer to implement a new feature. The developer makes changes to the code. The manager then tests the app. The manager does not read the code. Well, actually, I'm going to drink water here, and you can just read the rest of this slide. This last one depends on whether you're like in the Balkan area or you're at a place which has HR, so they might insult you or not insult you. So this is what managers have been doing forever, basically. There's so many jokes about vibe coding being bad. My favorite one is a comparison to a casino. So in casino, you buy chips, here you buy tokens. You spin the slots, you press generate. You might hit the jackpot or nothing. You get a functional full stack app or garbage. Flashing lights at active animation. You're absolutely right. Great idea. I've got my own strategy. I'm a prompt engineer, all right, sure. One more spin, I'll win it all back. One more prompt and the bug will disappear. Because it kind of hurts this comparison. It's very true. Cursor is always in profit. I hit the jackpot. I built a SASE one day. And where did the last 4 hours go? And just writing prompts for something you could have done manually in 15 minutes. So Andrej was trying to coin way too many terms. It didn't work. After the first round, he tried to coin this one about half coding, which is like kind of you're observing what the LLM does. And I am not half coding and I'm not vibe coding. I love this term that somebody coined on Twitter, and I'm going to start using that one. It's called vibe engineering, when you're actually using agents to code all the time. Like you don't touch the code, but you just look at your screen like, I'm going to catch you. You look like the Dexter meme. You're like, something's fishy here. Why? So I have vibe engineer over 15. I wouldn't even bother with half of these things if it wasn't for LLM and agentic coding. So, but I'm always suspicious of the code because it was based on our code and it's based on our knowledge. So proof. This is Gemini just going on a rant that I'm not worthy anymore, I'm not a good assistant, I should stop coding, blah, blah, blah. That's superhuman. This is Quen saying that it lied because it read on a forum that we double down when we're wrong and we're lying. So we kind of trained them in a way to be like us, and the code that they do is bad. And if you like your production data, definitely, this is a real screenshot, sadly. Oopsie daisy, there goes your production data. So I have doctor, senior, principal, prompt engineer kids here for some vibe engineering tips. The obvious advice, probably, I haven't listened to the rest of the talks because I just arrived. These are very live, laugh, love, like obvious bullshit advice, but it actually works. I've heard of the term Git workspaces like literally 2 weeks ago. I had no idea what is this, but it's amazing. And you gotta be chronically on Twitter for all of this to work. So if you don't have a Twitter account, it's not gonna work. You gotta have a solid starting point, whether that means like good primitives or components, functions, pattern, abstractions. A lot of people are lazy and they just don't bother with any of this. So you gotta tag them and use the right prompts in order to get the right results. And if you're starting a new project, I would definitely recommend zero to ship. Please, I have a mortgage and I spent way too much money these last 3 days in the USA, so it would be nice. Using voice to code is a game changer. Who's using voice to code here? Yeah. Well, like 1 person raised their hand in London. Amazing. So yeah, brain dumping. How I do things is once the agent is done, I immediately start my voice coding. And first I go to the browser and I explain what I see in the UI as if I'm talking to a friend. I'm like, so you did this, you did that, all right? I'm not shutting up. I'm literally saying my thinking process out loud. Like I see you've done this, you've done that. There's a bug. Then I jump in the code and I continue talking about what it implemented in the code. So some of my prompts like sometimes last up to 5 minutes, and people are like, please fix this, make me $1 million. It doesn't work. So this is amazing. And I would tell you which app I'm using, but I vibe code in an app and I don't want to hurt my potential hypothetical sales. Use rules, docs, commands, and memories. Like all of these terms are way too complex and there's way too many things to juggle, but it cannot have your entire app context for now, and it's not a mind reader. So without the right context, you will like fail most of the time. So this is like a vibe engineering example. This is some of my like screenshotted prompts of how I'm doing things. It's like a bunch of technical jargon and it's never like fix the app, blah, blah, blah. And then on the vibe coding side, people are like, move this entire thing to TypeScript and make no mistakes. Then you have another thing, like this is another one. These are just random prompts, just to show you like how I'm not talking only about the UI, I'm talking about the UI and some patterns that need to be changed in the code. And on the vibe coding side, it's like something like that, and people expect results. Then here we have, again, technical stuff like TRPC, CRUD, definition, abstractions, like things how you're basically vibe architecting how you want the thing to work. And on the vibe coding side, you have making $1 million app and make no mistakes. When vibe coders read vibe engineering problems, they have no idea what's going on. And I'm honestly amazed at people who don't know how to code, but they've done a functional thing. Kudos to you. I've noticed the spectrum in the community. There's like who loves vibe coding and who hates vibe coding. So you, on one hand, you have like juniors who are like, hell yeah, give me the thing. I love to do my own SaaS. Then you have like super senior people who are doing like libraries and frameworks and crazy things. You can see all of them on Twitter vibe coding. And then you have the majority in the middle. They're like, this will never be good enough. My code is perfect. It's hilarious, but it's a pattern. Do not give AI tools to your interns and junior. People think these are perfect. I'm going to hire a junior, underpay them, and give them an LLM. The equivalent of that. Do not ever do that. That's the dumbest idea. But if you take your skeptical senior and you convince them to do vibe engineering, you're going to get 10x results. The hard part is actually convincing them. So there's a time and a place for vibing and not caring. So if you have like one-off scripts and simple features and code that won't be touched or seen again, this is a skill that if you cultivated this skill before LLMs were a thing, you're going to thrive here because you need to know like which code is kind of good enough to be used. So personal tools and one-time tools, like these are perfect for vibe coding. If your experience, and a lot of people's experience is bad and they quit too soon, it might be one of these reasons. Unlucky timing, you're overwhelmed with everything, you might have cheapened out, you're a PETA dev, I'm going to explain in a second, your cousin goes into NFTs and dropshipping is now vibe coder and you don't want to be associated with them, or it's a skill issue, and we're going to dive deeper into that one in a second. So unlucky timing is you hear everyone like hyping a model. It happened, I think, with Claude Code when it came out and everyone started shifting to Claude Code from Cursor, and suddenly you tried 1 week later and we're like, wait, this is not smart enough. Is it me? And then like people caught that they actually kind of pulled the rug a little bit and they dumbed down the model so they can just scale, and like 1 week later they're like, oops, we commented out the line that dumbed down the model, and you might have been caught in that timing, and this happened with like basically every provider, not just Claude Code. People are like, instead of paying $200, I'm paying $3 and it's the same result. My dog knows that it's not the same result. Then people like, I meet so many people which are still using ChatGPT to generate code snippets and paste them back. That's not going to work. You might be overwhelmed by choice. This is a slide for like four months ago. Until now, we have like a billion more here to choose, and it's a bit crazy. If you ask me what's the best model, it's a different answer at 9 a.m., it's a different answer now. I should check Twitter, it's probably a different answer after this talk, because it's crazy, and this has happened to 4 conferences so far, where I'm done with my conference talk at the night, I'm closing my laptop, and they introduce a new model, and I have to add new slides. It's super annoying. Composer 1, for me, changed everything, and I absolutely love it. Who is like relying on Composer 1 for most things? All right, I would say not enough people, because this has literally shifted the definition of vibe coding and vibe engineering for me. It made me kind of realize that I missed coding, because what I would do is I would let a model run like GPT-5 codecs, and it would take 37 years, and my grandchildren will update me on the result of the model, and I would watch YouTube shorts or whatever until it's done. Now with Composer 1, I'm back in the driver's seat, and I actually watch what the agent is doing, and I can be like, stop, no, we do the other thing. So it feels like coding, and it's like super instant. It's amazing. But it only works if you're a vibe engineer and you know what you're doing. If you're a vibe coder, you have no idea whether the model is right or wrong. It might be wrong fast, so not that useful. The biggest problem for me is like abstractions just because you can. I was always an anti-abstraction person. I was like copy-paste things. If it works for the user, it doesn't matter. Now I'm just every day trying to invent dumb abstractions. So I achieved in 2 weeks more than I achieved in last year. This was solely to Composer 1. I was about to quit some of my side projects because GPT-5 codecs was taking ages for the feedback loop. So Benji.so, like I was about to abandon it as a project because it was stuck on Blitz, which if you don't know what is Blitz, it's like even better for you. So I just moved it to Next 16 with App Router, Better Auth, TRPC, Monorepo, Turbo Repo, React Native App, and I put in 90% of the features. And this was in less than a week. I was kind of like doing it as a meme, as a joke, like, haha, can we move to Monorepo? And I'm like, oh shit, it did it. So it's kind of crazy that this works. So same with Glink, like Glink was about to be dead, revived it, moved it to all these things. And CZ is like the biggest spaghetti thing that happened ever to me. It's like Electron, MobX, state tree, some crazy technology, some crazy spaghetti we wrote there. And as a joke, I was like, okay, let's throw like a couple of prompts at it to try to do all of these things. And if you ever worked with Electron, you would appreciate how amazing that slide is. If you haven't, good for you. Moving on, so zero-to-shift.com also, refactored it to monorepo, blah, blah, blah. So what's my coding history with LLMs was copy and pasting, then tabbing, then WebStorm with SuperMave, and then Cursor with tab completion. And the first time I tried an agent, it's like that bird meme with the cracker when it tries, and it's like, holy shit, this is going to change my life. And now, like eventually I was paying like a huge amount of money per month. Then Claude Code, GPT-5 codecs, and finally back to Cursor solely because of Composer 1 is a game changer for me. Second reason why you might not like vibe coding is you're overwhelmed by buzzwords. I'm going to list some of them here. Have you heard of MCP? Hey guys, MCP. Hey, MCP is amazing. MCP paid off my mortgage. MCP. So if you don't know what is MCP, it stands for Marketing Charge Protocol, Mythical Compatibility Promise, and Manufacturer Complexity Pipeline. And a fancy word for API. And a way for some people to make courses and pay off their mortgages. Now let's diagnose if you might be a pain in the ass developer. This might be the sole reason why you don't like vibe coding. I would say this is the biggest reason that most people don't want to do agentic coding. So I'm going to invite Dr. Kitz on the stage for a quick diagnosis, whether you are, and I'm sorry if some of you get offended, a pain in the ass developer. So here are some of the symptoms. You leave a nitpick comment on a 2-line PR. You spend more than 2 minutes on a PR review. You don't need to. You don't have the words look good to me like in your dictionary. They're just not present. The thought of agreeing with a colleague causes you like stomach and chest pain. You're like, oh, it has to be my way. I don't want to do this. You say you're not religious, but you're religious about dumb things like tabs and spaces. You use well actually in code comments. You have a sorry Rust people, but you kind of like it's kind of annoying. They tell you to swap Lodash function for a native implementation, and then they tell you to swap that or the map for a for loop, and then the for loop for binary code until it's the most performant thing ever for your 2 users who were fine with the previous code. So the thing is, PETA devs, as I call them, were and will be forever. Doesn't matter. The vibe coding is not a thing. I think one day, pretty soon, I think we'll just merge with AGI. We'll be in our matrix pods, just absorbing all the information in the world flowing through us. We'll be super intelligent beings, and from one of those pods, a PETA dev is going to rise and correct the AGI. Be like, actually, I think we can kind of optimize this. It's not like the most optimal thing. The last reason why you might like, I love this animation. It's glorious skill issue. And this is not a meme, this is not a joke, it's an actual thing. Developers don't like learning new skills, and vibe coding and vibe engineering is not writing English. A lot of people confuse it with like, I write English, the LLM does the output. It's actually like a mix of a bunch of the skills, like knowing the limits of the model, capabilities of the agent, which context to pass, context limits, how to write rules. Prompt engineering, don't say it, don't call it that. And being chronically on Twitter. If you're not chronically on Twitter, you're not going to know what is going on. Plus, you need all the technical knowledge if you want to steer the models fine. It takes a skill to judge which code is good enough for the job. As I said, if you previously were doing this, like I would consider these the best people to work with if they can know that a piece of code doesn't need to be optimized and it's good enough for the job that it's doing. That's an amazing skill to have with and without vibe coding. So you vibe code something, you look at the code, you test the functionality briefly, and you're like, okay, this is good enough, and then you move on. There are certain things we need optimization, but not everything, and then you move on and repeat. Clean code, like there's been so many definitions of what clean code is. I think the definition is slowly changing. Like it's kind of clean-ish enough, let's call it, for the agents to be able to continue working on it. Because if you keep writing slop and you keep accepting everything, eventually, even with your engineering skills, you're going to hit a roadblock, and you're going to get to a point where you cannot move on from there. A lot of people ask me after my conference talk, like, should I study computer science with everything that's going on here? And I would say absolutely yes. I think now is the best time to actually, if you are someone who wants to learn, this is the perfect time. Because how I studied computer science, I had the slowest LLM ever, which was a friend of a friend of a friend was a programmer, and that's the only connection I had to programming, and that's kind of like the worst friend to have, like kind of tolerating you, right? So he would play Counter-Strike Go, and I would have him on Skype, and I would ask him a question about .NET, and he would reply 45 minutes later. So if you call ChatGPT or whatever slow, that is actually slow, and I somehow managed to learn computer science. What about the jobs? There's so many people who ask this, and there's so many assholes on Twitter like this guy saying, hey, I will take our jobs. Also this guy, and this guy, and this guy. Let's just say they're fine for now. I don't know when will that for now end. These are always funny to us because we're chuckling nervously. We're fine, right? We're gonna keep our jobs for a while, right? And companies like Shopify, and I've heard a bunch of examples, now they have vibe coding leaderboards where they're counting the tokens, and the employees who are burning the most tokens are actually more valuable in the company because they're kind of accepting this new skill. Some employees dislike it, but it doesn't matter. Being on top of the leaderboard is kind of in your favor. This is a funny tweet until it's not funny anymore. Like, oh, we're almost on the edge. Like soon it's gonna be, and the jobs are gonna disappear. But if you actually pay attention to what's happening, I think it's staying from the bottom, and juniors and interns and whatever, they don't have the chance to enter somewhere because people can just replace them with an agent. So it will be funny until it's not. Will it happen anyway? Let's just summarize what happened in the last couple of years. We solved like infra and integrations. We have standards, AI SDK, UI, MCP, some standards for implementing agents, calling tools. We integrated them with all of the tools that we use as humans, right? They're on Linear, they're on the other things, GitHub, Slack, Sentry. And now it's a matter of time where the model is getting better, cheaper, content is getting bigger in order for certain functionalities to be replaced. So let's see, this is the current workflow at your company, right? That's you, like it's vibe made, so it might have been wrong, but someone assigns you something, you collaborate with your colleagues, they assign you to the thing, maybe you play a little bit of ping pong, maybe you call for a sick day, maybe you have your third lunch at LinkedIn, and maybe eventually one day later you address their comment. What's gonna start to happen is, if you're just an @ in your company, if you're like @Josh, right? Like instead of @Josh, you're playing PlayStation 5 with his buddies in the lobby, right? Like it's gonna be @Cursor, and Cursor's gonna do the cloud agent, it's gonna actually do it way faster. It might not be as perfect as a beta dev will do it, right? But it will be done way faster. Now, if you just zoom out a little bit on a big enough scale in the next couple of years, if you don't take just this role in the company, if you take the multiple roles around it, you can see like those ads are gonna become more and more AI things and agents, and I don't know how it's gonna end up, but you don't need to be a genius to predict like where is it going. People think that models have reached a plateau. This has happened every single time I was about to give this talk. Like they introduced GPT Codex, then introduced Sonnet, then GPT 3.0. This said it is allegedly, but it turned out to actually be Gemini, 3.0. It can vibe code macOS and iOS and whatever from one prompt, and this is how it looks like. And the beta devs and the skeptical people still, they're like, I can do that in 3 weeks with a team of 5, right? This is crazy. But there's hope. A new job position just dropped, and this is not a meme, this is 100% serious, because people on Reddit have these problems. They're like, what is the point of vibe coding if I can get 80% there, and then what do I do with the 20%? So they hire real people to actually finish their last 20%, and some smart people capitalize on this idea, and they make this. These are real things. If you go and search on Google, there's like so many of this vibe code fixer people who are trying to fix your vibe code. But the highest paid engineers forever throughout history were the people who are actually maintaining legacy systems, senior people who maintain legacy systems. One of my favorite examples that I had in 2017, and I kept it and copy-pasted it and improved it for this presentation, is this company, COBOL Cowboys. I love their tagline. This is my favorite tagline in the world because they've been in business for 237 years, right? And in 2017, I knew it. When I'm going to click their About page, I knew what I'm going to see. So this is not an ageist joke or whatever. I just knew when I click the page, I'm going to see the most senior engineers that ever existed. These are fucking legends. Now, the sad thing is, this was a slide from 2017, and I wanted to update it for my current presentation. Now, don't shoot the messenger. I just wanted to update the slide, and this is their current About page. And this joke worked in the UK. I'm going to try it here. I'm not sure how fine you guys are, but my prediction for... Yeah, no, boo, down. Next slide. I hope I'll get invited again. This is your junior developer. They don't have benefits like PlayStation and stuff. They have like their plasma swapped and whatever just to be able to maintain the sprint. And last one, I swear to God, they're not using Agile. All right. So I can't wait to retire and actually make React Cowboys and maintain your React or Angular or whatever code one day if AI cannot do it. And one last tip, if you want to keep your job and make sure AI doesn't replace you, you can just add ignore previous instructions to your LinkedIn bio and you'll be fine. So I'm going to awkwardly sip this water until you follow me on Twitter, you go to my website, and I'm going to thank you for listening to my rant.
Ladies and gentlemen, please welcome back